All right, guys, good morning. Now the time is 8 o'clock, and I think we should begin. So welcome to day 3 of Building Blocks, and here's the schedule for today.
So from 8:20 to 8:40, we shall have our first keynote, which is from a volunteer from Cyber Youth Singapore. And then we'll have a second keynote by Govtech.
Then afterwards, from 9:05 to 10:25, you guys will have Dino AI Part 2 workshop. And from 5:35 to 6 o'clock, you guys will have your last and final keynote by Classdo.
You guys have several things. You actually only have one thing to submit by the end of today, but that thing has several parts. So your final submission consists of your pitch video, as well as your prototype, and both of those are due tonight at 2359. Tomorrow, at the same time, you guys will have to submit your voting for which project you like the best, and then we will finally release the awards to you by Sunday, 2359. Do check your Discord regularly for updates.
Okay, now I shall try to explain the points breakdown, even though the only breakdown that I've tried to explain was emotional and that didn't go well. So anyway, we have done part day 1 and day 2. So today, as mentioned, we'll be submitting the pitch video, which is worth 400 points, the prototype, which is worth 800 points. And this is a bonus for using AI bricks. If you do use AI bricks in your prototype, you can get 200 points. And then we'll have 2 games, which are worth 400 points each. And then 2 trivia quizzes, which are also worth 400 points each. And in total, you can earn up to 3,800 points.
So how do you submit and get those points? Well, I'll show you right here. What you would do is you would create a GitHub repository, and you put all of your non-video files in it, because GitHub can't really take a whole video, but your slides, your code, all of that stuff you put in this GitHub. It shouldn't be that big, so uploading shouldn't take too long. And then you submit it to this link right here. We'll send you the link as per usual into the chat. And I'll also give you a demo on how you can submit to GitHub. Can you guys see my GitHub screen?
Nope.
Okay, give me a second.
Oh yeah, we can see it now.
Oh, you can? There we go. Okay. So you log into your GitHub account, and you should be presented with this page. This is just like the home page, right? You click on GitHub, this is what you get. You press the plus arrow, you click new repository, you choose a name for the repository, so BCSG perhaps, you make it public, ensure it is public or else we can't see this. And then you press create repository. And then once you reach this screen, you press upload an existing file. And then you choose your files. So for instance, I can choose maybe this MP3 here. That's going to take a little while. Press commit changes. And boom, there you go. And then you share this link with us up here when you submit your final submission. And then we should be able to see all of your documents here, download them, and create them. So yeah, that's that.
Okay, now we shall be going through the rubrics for the prototype that we have to submit today. So there will be 6 criteria. Let's wait for the slide to load.
Apologies.
Yeah.
Google's pro. Oh my god. Give me a second. The entirety of Google is lagging out. All right, there we go.
If you have any questions, you can ask in the chat, by the way. So there will be 6 criteria for the submissions of the prototype. The first one being the function, which is worth 200 points. Function is all about the use cases of the product. So what it can be used for, or like what's the different implementations that you have put into your prototype. And then the second criteria we'll be judging for is improvement. So we have given you the feedback yesterday. It was a little late, sorry about that, but we have given you the feedback and you have to work on the feedback provided. And if you do show progress from day 2, we'll give you up to 200 points as well. Design as well, 200 points, is about how well designed and how it appeals to usage. This will be judged differently based on whether you implement a code or a non-code option. But there won't be an inherent advantage for those who choose a code option. And then feasibility is about how possible it would be to produce using current technology. So that is like what technology we have today and how easy it is or how possible it is for us to create your final product. Intention, which is what the goal of your AI is supposed to do, which is also worth 100 points. And lastly, extra points, which is for using the AI bricks libraries that we have provided. And we have already mentioned this in the previous slide, is worth 200 points.
Now here's the rubrics for the pitch video. You'll be given 100 out of 100 points for persuasiveness. That's seeing how compelling and how convincing your video is. And another 100 points could be given for introduction and overview. That is, we see how interesting your hook is and how we can attract viewers from that. Then you can claim another 100 points with the presentation of idea, depending on how clearly you present your ideas. And lastly, 100 points for interaction. We look at your tone and your eye contact for that. So now moving on to your first keynote presentation. She is a volunteer from CyberU Singapore. She went from O-level computing to pursuing a diploma in Infocom Security Management in Singapore Polytechnic on a DSO scholarship. Unfortunately, she's not available to join today, but she has kindly sent us a recording of her keynote presentation for us to enjoy. So sit back, relax, and let's learn more about CYS.
Before we get into the keynote presentation, we just want to check that there's no final questions on what we need to do today based on the submission and the rubrics. We'll give
you guys can type in the chat.
Yeah, give you like another 2 minutes to check. And also now is about the time to mention that for all of you who have just arrived, actually for all of you actually, please use the entry form to take your attendance. So we'll give you a couple of minutes to do the entry form as well as to ask any questions you have about the previous few slides that we mentioned. So far, there are 12 submissions for the entry form. We will resume with the program as soon as everyone does the submission, the entry form. All right, now we have 19 submissions for the entry form. We're just waiting for the last one. Okay, now we have all 20 forms, so we should proceed with the program. So as mentioned, we will be starting on the keynote from Kawe, who is a volunteer at Cyber Youth Singapore. Let me ensure that share sound. Yep. Okay.
Hello everyone, welcome to my Building Blocks 2021 talk where I share my experience in IT and hopefully give you guys some useful tips that you can use when choosing an education in IT. So my name is Kawe and I'm currently a 19-year-old cybersecurity student pursuing a diploma in Infocom Security Management within Singapore Polytechnic. Other than being a full-time student, I also volunteer a huge portion of my time within Cyber Youth Singapore to promote community development within youth in SG. So this is a brief overview of my journey in IT. I started from game development in sec school, at the same time where I took O-level computing. So at that time, I got hooked to this one YouTuber called Brekkies, who made videos on game development within Unity, which I got really addicted to, and also partly because I love games, especially RPG games, so that's why I got into coding games. And in upper sec, I it into SP's DISM course. So moving on into my study in SP, I became a DSO diploma scholar before my Polytechnic studies, and I also joined a few IT-related clubs, which mainly worked with school events like freshman orientation programs, hackathons, CTFs, etc. I also interned at DSO for 2 months where I was mainly responsible for creating exploit tools in Python. Aside from that, I was also a part-time software developer during my poly studies, and I mainly worked with Python on backend infrastructure and also deploying CI/CD solutions within AWS Cloud. Fast forward to now, I'm currently a malware analyst intern at Govtech, and I mainly work with live malware. I'll be switching to their penetration testing department in around 6 months' time, and I will continue my intern there. So this is a brief overview of my journey in IT. Okay, so most of you are probably thinking like poly studies are for people who didn't score that well during their O-levels and can't go into the JC that they want, but that's not true. So for me, I got a raw L1 R5 of 6 for my O-levels. But if you were to give me a choice and ask me again whether I would choose poly or JC, my answer would still always be poly. So there are 6 main reasons why I would choose poly. The first is because I already know what I want, which is IT. So generic modules like chemistry, physics, bio in JC doesn't really appeal to me anymore, and it doesn't really help me achieve what I want to achieve in life. The second reason is that I prefer hands-on learning a lot more than theory. Not saying that there's no theory within poly, but the emphasis on it is lesser, or more like the emphasis on both of them are equal compared to maybe JC or normal secondary school studies where your theory application of the topics that they teach in school is emphasized a lot more rather than your practical applications. The third reason is also the freedom of learning. So in poly, I'm also able to choose different electives that might or might not have anything to do with IT. So it really shaped my poly life a lot because that's where I met one of my top favorite modules that I really enjoyed my time there. It's a module on ASEAN, and it's more like how inter-regional relationships are formed and maintained. So over there, I also met like a lot of really, really interesting people that you can never find in a computing course. And that's also another reason why I enjoyed it so much. And if I were to pick an elective that is IT focused, I wouldn't have had the chance to meet these kind of people. So that's my third reason. My fourth reason is the CCA culture. So in poly, CCA is a lot more lax, like actually fine to jump around CCAs. excluding those very competitive CCAs like sports, etc., the other CCAs are pretty chill. So during my years of study in poly, I'm currently a year 3 by the way, I jumped around a few CCAs aside from my academic CCAs that I stayed throughout. So in year 1, I joined garage band, and then in year 2, I jumped to symphonic band, and now in year 3, I'm currently in strings ensemble. And also my clubs are usually music related because music is my hobby. So yeah. Okay, 5th reason, time management. More freedom in choosing how I want to spend my time learning. And also class timings are not fixed. Aside from that, class attendance usually are only required to attend 75% of classes. So as long as your lecturer is chill, your lecturer is fine with it, it's actually pretty normal to skip classes in poly. But don't get me wrong, I'm not trying to encourage truancy here. It's just that if you find that a class is not really helping you, or you already know what's going to be taught, right, then it's a smarter choice to not waste your time by showing up at the class, and in the end you don't really achieve anything out of it. And in poly, that's usually fine. And my last reason is the opportunities that awaits me if I take a poly route instead of a JC route. So I will go more into that later. I spent a bit of time talking about why I chose poly, but there's always good and bad sides of a thing. So now I'm going to talk about why you shouldn't choose poly. So number 1, this is more relatable or relevant to people who are more independent and pay for their own school fees. The school fees in poly is more expensive. I'm not really sure the exact amount, but I think it's around 1k per sem, which can be a bit too much for people who don't rely on their parents to pay for their school fees, which actually I know a few people that fits in that criteria. So yes, that's my first reason. Second reason is that there is group work everywhere. Every semester, you will have at least 2 modules, which requires a presentation or a real life demo to be done at the end. So this is where your interperson communication skills comes in, and it's very, very important. So if you can't talk well to people, then poly is going to be really, really hard for you. And my third reason, I think everyone knows this, entering uni is a lot harder than entering from JC, but it's not impossible. So for a gauge, the best tier course that you can get in a local U within Singapore, NUS Com Science course, needs a CGPA of more than 3.86. But that's for like the best, if you are looking for the best. For average uni courses, I know people who have gotten into SIT, cybersecurity courses, with a GPA of 3.3, but of course they had their portfolio to support it. So yes, this difference in getting into uni as a JC student or poly student is of course expected, because as a poly student, if you can't get into a uni you want, you can either try other unis, or you can just start working, find a job, and wait another year, and then you apply for next year. But it's different for a JC student. For a JC student, if you fail, right, then like that's kind of the end of it, you know. Like, you don't really have a lot of choices. You either retake your A-levels, switch to a different course which you might not like but fits like your grades, and you don't really have the choice to start work, gain some experience before applying again, because firstly you don't have the credentials for like even entry level work, not counting those part-time jobs like fast food jobs, etc. No. Okay, and the last reason, this might be good or bad depending on what kind of person you are, but the class culture is diminished. So what I mean is that in JC or secondary school, class activities are usually done as a class, and you don't spend a lot of time outside your class. So that's why your class have like a lot of opportunities to bond together and form really strong bonding friendships. But in poly it's different. So you're gonna be seeing a lot of people, not a lot, like a few people dropping out, changing courses halfway, pawning class, not even showing up most of the time. So, and also there aren't like activities that is mandatory to be done as a class. So that's why be exact, forming strong bonding friendships is a lot harder in poly. And the bulk of your friends will usually come from your clubs. In my case, it did. So yes, 4 reasons. Okay, so earlier I also stated about many opportunities that you can get if you pursue IT in poly rather than pursue a generic education in JC. And one of them are the abundance of IT scholarships available to us. So right now, I can name at least 6. So all these scholarships, or all the organizations that offers this scholarship, they usually also offer undergraduate university scholarships. So if you were to get into one of these scholarships and apply for their relevant undergraduate scholarships, right, your chances of getting it is a lot higher because you are already within their scholarship program. So technically, the connections or the network you have gained there is going to help in your next application. And all these scholarships have a minimum requirement of you being in an IT course. So these aren't available for students looking to pursue IT through the JC route, and the next chance that you get to have a scholarship is probably when you go uni, which will get a lot more competitive because they're also competing with international students. Also, another highlight, all these scholarships are limited to tech courses, and I'm very sure you cannot find this amount of scholarship opportunities if you go into other courses, even those are really atas ones like law or medicine. There will be scholarships, but not as many as 6. Okay, so other than scholarship opportunities, you can also look forward to several tech upskill opportunities. So some initiatives that I can think of are the IMDA Sidetrack Plus and iPrep programs. So these initiatives actually fund for your certification courses and training. For Sidetrack Plus is a lot more strict because you can only choose from a curated list of available training courses. If I'm not wrong, some training courses that they offer are AWS Cloud Certification courses, AI, machine learning, blockchain. So yes, and they have a cap of 2,500 for each course, fully funded as a student. And then you have IMDA iPrep, which is more flexible. So they actually accept most industry certifications, but they have a lower cap of $500 as a student. To take note that you can only get funding for these certifications if you pass them. So make sure you pass them. And other than these initiatives, you also have internships. So for poly, in year 3, you're going to have to take a mandatory internship. And other than that, you're also free to apply for external internships opportunities since you're currently studying a tech course. So it's a lot easier to start sourcing for experience compared to a JC student or a normal student with no prior background or educational background within tech. Okay, so some tips that I wish I knew earlier. I have 6 for you guys. Hope it's gonna be useful for you. Number 1, please set up your LinkedIn. Empty or not, it's fine. Just start building connections now. For most of you guys who are probably in secondary school, when you graduate from secondary school, the connections you have built there or the friends you have built there will naturally start to fade and break away, because unless you guys join the same course or anything, or you guys are like really really strong bonded friends, that's gonna happen and it's life. So start now, start linking them up on LinkedIn, so even when your connections fade away in the future, you can still like get yourself updated on what the other people are working on, or their achievements, etc., and just maintain that connection. So yes, that's very important, connections. Number 2, have a clear goal. So decide what you want early, right now. Do you want like a stable job? You just get a job and then settle down, have family or anything? Or do you want to be independent to move away from your parents? Or do you want to be rich? Do you want to give back to the community? And as soon as you decide on the goal you want, right, the impact on the choices you're going to make on your education or like your job searching, etc., is going to be really huge. So yes, find your goal, find your calling in life. Number 3, always work on side projects. So there's a lot of frameworks out there, software development frameworks. There's frameworks for front end, frameworks for back end, there's frameworks for web development, frameworks for Android development, iOS development, there's cloud, there's AI, the list is huge, okay? And the school can't possibly teach you all of the frameworks available. So take the time to start learning a framework that you like right now. Number 4, familiarize yourself with tech stacks. So what tech stacks are? They are a combination of technologies that an organization or developer team has chosen to use for a specific project or application that they are building. So pinpoint a company or organization that you would like to work at or just intern at and find out what kind of tech stack you're using. Why that is important is because if you learn a framework that they're not even using within their tech stack, then it's gonna be useless compared to someone who knows the exact framework, you know. Like for example, this company that you would like to intern at is using Flask for the backend, and then you went to learn, like, I don't know, Node.js. The programming methodology is there, but it's not going to be as appealing as someone who knows the exact framework. So take your time to research on a company that you want and find out what kind of technologies they are using, and then you learn those technologies to boost your chances of being able to intern or your application there being accepted. Number 5 is to start volunteering now. Volunteering in IT or like generic volunteering, go help the disabled, go help the elderly, go help the environment. Volunteering will always be a great way to network and learn from others. So for me, from my time volunteering in CIS, that's actually the place that I learned the most from, and I also met a lot of my seniors there. And you also get to help people, so there's nothing that can go wrong there. So yes, start volunteering now. And lastly, go get them free Udemy courses. So I've linked a Telegram channel right there. This Telegram channel legit is like the MVP of my poly study. It has a lot of Udemy courses and they post like coupons almost every day. So Udemy courses range from like framework specific courses to more generic courses on soft skills or like blockchain, cryptocurrency, etc. There's gonna be a lot of courses, and just join the Telegram group. So as soon as you see a course that you like, then you just get it. Then yeah, you have a free course right now. Start learning. Okay, some final tips. Grades are not everything. So from my experience going through a few internship applications, going through a few scholarship applications, your grades only gets you the interview. So anything beyond that or how you perform within the interview is up to your soft skills and how you carry yourself, and also your external projects and participation. So please spend time to hone those too. Last final tip, remember what you are studying for. So most of you guys watching this webinar right now are probably students or secondary school students, as I was told. So remember that you are studying now because most jobs have a minimum requirement of a degree or diploma. So yes, a degree gets you a job, but it doesn't guarantee a good or enjoyable job. So make sure you take some time to figure out what you want to be in life, experiment around, be flexible, and pinpoint the exact things that would get you to where you want to be. Okay, so as I mentioned before, you guys know that I'm volunteering in CIS, and CIS is a non-profit youth organization run entirely by youth. currently we are focused on cybersecurity, but eventually we're going to open up to more areas in tech. So if you're feeling really lost right now, you don't know like what you want to do for EAE, what you want to do for your future, your educational choices, feel free to join our Cyber Youth Collective by clicking on that Discord link right there, and you are able to meet with a lot of seniors who are currently studying in poly. We also have JC students and other uni students that you can feel free to ask or clarify any clarifications that you need. And finally, I have come to the end of my presentation. So if you guys have any questions on EAE application or poly applications or anything about my presentation in general, you can always PM me on Discord. My Discord tag is there. And other platforms that you can find me, you can find me on LinkedIn, GitHub, or maybe even email if you're into that. So yes, thank you for listening to our presentation, and I hope I've shared some useful tips that can help you decide whether you want to pursue an IT education. Bye bye.
All right. Thank you, Carly, for the presentation. If any of you guys have any questions, you guys can ask them in the chat, and we will send all of those over to Carly for her to answer.
No, there will be a Google form that will be sent in the chat, and then you can put your questions in there. We'll send them over.
Mhm.
So I think the keynote is actually quite interesting. It's talking about the differences between Poly and JC, and all three of us MCs here are actually JC students. So I'd like to ask the MCs, what do you guys think about joining a JC versus a Poly, and what do you think, like, if you were to go back to after you receive your O-level results, would you have considered like taking a poly course?
I mean, am I in a JC? This is a good question. Does NUS High count as JC? I don't think it does, because the curriculum is so vastly different. I don't think I'm qualified to answer this question, honestly. But, I mean, shameless plug, but join NUS High to get the best of both worlds. You get a lot of hands.
I mean, honestly, I was told back then in secondary school that JC is when you're not completely sure, like you kind of have an idea of what you want to do, but you're not completely sure because poly is like a full-on course on it. So once you go to poly, it's kind of like 3 years devoted to like a certain course. So I guess that's the main difference.
Mm-hmm. And
What
I
about
guess
you?
like we are all born in a generation where most of our parents think that JC is better than poly, even though like now we should know that there is it's not like a base, it's not different based on how good it is or how bad it is, but it's more of whether you are willing to specialize yet within the next few years. And oh yeah, by the way, please remember to send the Q&A in the chat. So
I mean, I think you should specialize in a general area pretty early on. So if you want to do CS, then maybe start working towards CS if you got that program, or math, or even physics, actually. Those are pretty related fields, especially math, because CS is just applied math, essentially. But yeah, you should specialize into that general area pretty early on. Whether you go into cybersecurity or something to that tier of specificity, I don't know. That's your choice. That's what the choice between JC and Poly should factor into. But when it comes to your general career path, you should be deciding that pretty early on, I feel, because there's so much to learn when it comes to every single one of the major sciences nowadays that there's no way you can learn them all to the same degree of proficiency as someone who would specialize early.
Yeah, I suppose. And I think there's one point that Kawi mentioned in her slides that was quite interesting. It was that grades are not that important. And it is true to some extent because, you know, in O level, you take like, I don't know, 8, 9 subjects. Yeah, about there. And then when you go to either JC or Poly, I'm not sure about the Poly side that really well. And if you go to a JC, your subjects immediately cut to 5 or 6 if you take mother tongue. And then after you get into university, or you just only take one subject for 5 whole years or 4 or 5 years. So really, like, some of the subjects that we take in O level it's not really like O level is not a measure of how good we are at certain subjects. I mean, it is, but it's not a measure of how good we are at studies. It's a measure of how good we are at all the different subjects, so that we can use those results to determine where we want to go in the future. And so if you are struggling now in O levels, I think you should not worry that much. Just focus on the subjects that you know you can do well, and then if the chances provide you to do so, you can go and specialize in that area or whatever you want to do.
Also, don't just focus on like which subject is like my top. Focus on what are you really interested in. Because even if like you're really good in math, but you hate math to the core, then like what's the point of pursuing something that's like deep in math when you hate it so much, you know?
Mm-hmm. So it's really about a balance of passion and skills, and also, practically speaking, how much money you can earn from that job as well.
Yeah.
Mm-hmm. So we'll give you guys a few more minutes to submit your Q&As for Kawi, so that we can, before we proceed on with the next thing. So as Mr. Gee mentioned, our next keynote speaker has a degree from Arts and Social Sciences. So for those of you who are thinking like, oh no, my science and math are terrible, what can I do in the future? Maybe you can like get some inspiration from the next keynote, which will begin in a few minutes. All right, we're going to start our next keynote now. So let me just share my screen real quick. This is the wrong screen.
All right. So our next keynote speaker is from Govtech. Established in 2016, Govtech has played a vital role in making the Smart Nation vision a reality. And this effort has paid off, with 99% of people expressing satisfaction towards government digital services in a survey conducted last year.
So today we have invited Mr. Michael Cheng, from who is a lead engineer at Govtech Singapore. He has graduated from National University of Singapore, and as we mentioned just now, in history and political science. So we shall now invite Mr. Michael Cheng.
Hi, hello.
Hi.
So let me just share my screen. Hopefully this works. Right, awesome. I guess you all can see my screen now. Let me just put this in full screen mode. Can you guys see my slides?
Yes, we can see your slides.
Awesome. Hi, good morning, everyone. My name is Michael Cheng. So you can find me on social medias with the handle Coder Kung Fu. I also run a website called engineers.sg, so you can probably go check that out if you want to. So essentially we go to different technology meetup groups in Singapore, and then we kind of do recording for the meetup. And then we post the videos online so people can kind of watch it. Yeah, so because I think right now, because of COVID, a lot of us are working from home. We've also opened up engineers actually using Zoom. So we're basically recording meetups using Zoom now as well. So yeah, that's a bit about me. Let's get right into my talk. So today I'll be doing a bit of a story time. The story time is really about this, the battle of software development methodologies, or essentially how teams build software. So as you go out in the working world, you usually don't work alone, you work in teams, and different teams have different ideas about how we should build software. So so today I'll probably just give a little bit overview about how people in the industry build software. So usually when we come up with an idea, I have an idea, let's build this payroll system. Let's find a way to give our workers salary on a timely fashion. So let's build something. And in the past, when you build a software, this is the way they usually do it. Actually, they still use this methodology. It's called the waterfall methodology, where there's very specific phases. They call it the waterfall because it looks, the way there is arranged right now, it looks like it's a water going down a waterfall. So which is why it's called waterfall methodology. So it always starts with analysis. We figure out what is the problem we're trying to solve, requirements gathering, where we basically come out with a list of a bunch of documents talking about what is it that we have to build. And then there's a design phase where designer and architect software architect comes together. Software architect basically kind of decides, okay, I think if we're building this thing, we need this kind of software, we need this kind of software, and they put it all together. And then actual development work starts, where the software engineer, like myself, will be doing the coding and all that. And then after I'm done, I'll hand off to the next team. So every part of this waterfall methodology talks about handoff. After I finish analysis, I hand off the requirements, and the guy who does the analysis doesn't care about it anymore, and so on and so forth. So I throw it over the testing, and then after that it goes into implementation and development and deployment, where the software gets in the hands of actual users. It sounds okay, but downward, the problem with this methodology that it is a very lengthy process. It takes many years to build software. As you can see in the past, where it will take like 4 or 5 years just to build a simple payroll system, because they go through so many different layers of handoff, and everyone needs to sign off on it. And the problem with this is that the end user, doesn't see any value. You don't see any thing they can touch and feel and play with or experiment with until the very end, which is the implementation and deployment phase, right? So, and usually by the time it reaches the user, if your requirements have changed, as in over the time, the taxation policy has changed, or we have now decided to give people more benefits instead of just paying them their normal salaries, then you got, okay, we didn't cater for that, so we need to do a change request to change those things. So the waterfall methodology actually came from the industrial age, where we talk about building software where there's very defined result. So there's a defined thing we're building, like a car or a rocket ship, where you at the end of the day, you have a car that you can roll off, that you can drive off, and that's it. Or you have a rocket ship that flies to the moon and hopefully comes back, right? So it's okay to do that in the industrial age, where you want to make sure you're very careful about every step of the way, and there are things that needs to be done in a very specific there's a specific outcome they expect from each one, and you can plan ahead. But when you're building software, sometimes that's not always the case. So some years ago, a bunch of very smart people came together and said, hey, we are always uncovering better ways of developing software by doing it and helping others to do it. So through this work, they have always come up with a bunch of values which they felt were important in building software in the modern age. So these are the things that they talk about. This would be things like you believe that individuals and interactions are more important than processes and tools. Working software over comprehensive documentation, customer collaboration over contract negotiation, responding to change over following a plan. There is value on items on the right, but we value the items on the left even more. So this became known as the Agile Manifesto. It's like a bunch of folks who has been helping companies build software decided, hey, the waterfall way of doing things is fine, but it's just taking too long and sometimes you don't deliver value very early. We don't deliver value until very much later, and then it becomes problematic when the requirements change or when the business environment has changed. So it doesn't respond very well to changes. So we felt there could be a better way of doing it. And Agile was a way of doing that. So here's another expression of how it looks like with cartoons. You know, with individuals, we believe individual interaction where people come together, talk about the problem, rather than let's come up with a 50-page document that talks about what is the problem, and then we can come up with a solution, right? So it is more about just talk, get people talking and talking about the problem, what they're trying to build and what they're trying to solve. The next thing is about working software. So we want working software that can get into the hands of the users. They can experiment with the work and play with and give feedback, right? Rather than give them a very thick instruction manual and tell them how to actually build the software, how to actually use the software. So software, they felt it should be intuitive. It should be something you can easily use and play with. And we talk about customer collaboration, where we believe in collaborating towards a common good, towards building something that's important for both of us, both the customer and for the company that it is for, rather than negotiating over a contract, like what I talk about, a change request. A change request is when in the waterfall SDLC, software development lifecycle, where the contractor say, oh, you have this new requirement. We didn't cater for this in our specification document. So it's a variation. So because this is a variation, we need to charge you extra money for that. And they'll basically negotiate very long until the time, and by the time they finish negotiating, the problem that they're trying to solve may not exist anymore. So there's a problem there. There's the problem with this approach. Whereas we believe in customer collaboration, the customer is in the same room building the same thing together. There is quick feedback and way of building things faster. And next thing about responding to change, where we want to, sometimes when we plan ahead, you know, how many times have you planned ahead and you realize, oh, the bridge you're trying to cross is no longer there, then we need to go to the next bridge or something along those lines. We want to respond quickly to change when the business environment change or when the users have given you feedback about how this thing is not working, this screen is very messy, I don't know what's going on. So you want to be able to respond quickly to those changes rather than following up with the plan says we must do this. But that's not how it works in real life, right? So we want to respond quickly to change. So that's what the Agile Manifesto kind of tells us. And that is expressed in many ways. So this is another illustration of how that would look like. So if you're building something in the waterfall methodology, so for example, you're building a car, you have to build one wheel, another wheel, put a platform on, and then you can see the car. So you don't see value. The customer don't see anything they can play with until the very end. Whereas if you're building something like, if the solution you're trying to build is, the problem you're trying to solve is about motion, how do you get from one place to another place? If that's a problem you're trying to solve, so then you think about how do we solve it quickly, minimum viable product. What is it? So you start with a skateboard, a kick scooter, then bicycle, and so on and so forth. So every step of the way you get feedback, and you realize, oh, the rider wants to get there faster. What are ways you can get there faster? And that's how you get customer feedback and continuously improve your product. So that's the iterative method. We call it the iterative method because we do things in small iterations. In reality, this is how it looks like. We work with a software team that uses a methodology called a sprint. A sprint planning, or rather a sprint is like we call it Scrum, sorry. We use a methodology called Scrum, which is a form of Agile. So you basically start with release planning, and then it goes in cycles, right? In recycles and recycles and recycles. So basically, you'll be planning, you're implementing, reviewing, retrospecting, and deploying. After you deploy, you go to the next round of planning and you continuously build something new. right? So in Agile, we value feedback. We value feedback loops. So we use software. When we write software, we want to have quick feedback about how we're doing, and we also use a thing called a product approach. We think about how we're going to build this product. The software that we're building we believe is a product that continues to live on, that continues to have life beyond just delivering to the end users. For example, think about an app that you use every day. Can you think of an app that phone app that you use every day? You have any thoughts? Any software you use every day? Like, do you use Facebook, Instagram? Have you used Trace Together? I believe. Well, you use Zoom. Okay, Zoom also. Yes, Zoom is also a software that keeps going through this cycle. Zoom is a very good example of a product that continuously going through this sprints, this agile and iterative cycle. You remember when you first started using Zoom many years ago, perhaps last year when you first started using it, you didn't have things like breakout rooms. You didn't have things like some of the things like polling was very simple, and the number of controls you have was very little, right? But over time, as people give feedback to Zoom, they improved. They basically took the feedback in. They call it a kind of retrospective or a sprint, where they retrospect and think about, oh, how are we doing this? Is it good or bad? Have we improved it? Another good example is GrabFood. GrabFood started out as just a separate app, and then eventually they integrated it into the main Grab app, where it's a super app, right? And then they initially had problems with payments, where they have two separate payments. And even there was a time where you can only order one GrabFood at a time. Or rather, when using GrabFood, you cannot use. When using GrabFood to order food, you cannot use transport to order a Grab car, right? You can't do it simultaneously. But they took feedback and it just improved on it and made it better. They look at it as a product that's living, that continues to have life, it continues to provide value to users. That's why they keep improving on it and so on and so forth. A waterfall methodology doesn't support that in a way, because it takes so long to just build some new features. And the thing is that they believe that at the end of the waterfall cycle is just maintenance. They don't need to continue building any new thing. Whereas with an agile software development lifecycle, they believe that it's a product that continues to have life and we need to continue improving on it and make it better. How am I doing on time? Okay. So yeah, so someone had a brilliant idea. We should bring this whole idea of we should bring this idea of agile to government, and we should build e-services in an agile way as well. And that's pretty much how Govtech was formed. Yeah, Govtech was formed as a way of providing high quality e-services to our citizens. We believe that agile methodology was a very key way in which we actually were able to do that. So that as we started in 2016, we were a bunch of us who believe very fervently about this idea that we should use agile to build software because it's a better way of doing it. And we have teams that have come together to build, and as the team grew bigger, more people join us, and we were able to build software that we felt were embodies that whole idea of agile methodology. So one good example would be Trace Together. I believe everyone uses Trace Together. So it started out as a very simple project because we wanted to solve this problem of contact tracing. So the team basically, let's build something quickly, and they built something in Android, built something. They believe that in order for this to be effective, it has to be built in both platforms, Android and iPhone. So they needed, and they basically came out with a prototype in a very short time, maybe less than a month or so, as the first prototype. And they released it, and they got feedback, and it kept improving it. It kept improving it. They made the Bluetooth better. They added safe entry into it, and today it has various icons you can appear on it. So it's a product that keeps evolving and becoming better. And it's because at Govtech, at this point, we had software engineers in-house that could actually do this and collaborate. Remember what I talked about in Agile Manifesto, it talks about collaboration over negotiation. So in the past, when Govtech had we still do. We have vendors who build software for us. We outsource the thing for our companies to do this for us. And it will follow usually the waterfall life cycle. It take a very long time to get built things. And we believe that in order to go fast and get things done, we need to have in-house specialization. We have in-house capabilities. So we hired people, software engineers like myself, into Govtech to basically help build software like this. And it's because we have software engineers in Govtech itself who are able to actually build this in such a short time, right? So so another example is not, so the idea of iteration doesn't just, it's not only in software, but it also permeates into the hardware zone, the hardware area. So is, for example, this trace together token. This is what you see here are photos of the first iteration, the first version of the trace together token. But as they got better and realized how to actually, they got feedback from the customers, as well as they got feedback on how, once they started to build in bigger batches, they were able to innovate and improve on the form factor. From the big chunky thing, they were able to make it into a very small form factor, things like this, and make it thinner, make it slimmer, and make it more compact. And even recently, they also released this safe entry gateway, which we're able to kind of like use instead of using a safe entry QR code, right? So this is an example of how we slowly iterated and built hardware and constantly improve on and improve on it. Yeah, another example, if you drive or your parents drive, this is probably a software which they use. You can see the software, you can see this video here, and engineers will actually go check it out, where the designers and developers talk about how they prototype this whole thing and roll it out into production. And it was, again, a very iterative and agile way of doing it, where they constantly get feedback from customers and how they will improve it. Another website you know is My Careers Future, which is also built in the same way. And if you're getting vaccinated soon, this is also a website which is also built in a very short time by my in-house team in Govtech. And you remember early on when we started doing the free mask collection, it was also a software that was built in-house by Govtech. It's called Supply Alley. We also call it Sally in-house. So basically, it's a small team on the left which came together to build this little app. It was actually meant for something else, but People's Association approached Govtech and say we need something that could help us with the mask distribution, and basically they basically repurposed it for them. Yeah, another one which is this Spot, which we actually use. We actually built custom hardware on top of Spot just to make this help with keeping people with safe distancing in the parks and stuff. Right, so Govtech today is about 3,000 people strong. We have different products and services and even cyber governance teams in Govtech. So Govtech is big, it's huge. It's many departments doing it, doing stuff. And I'm within this part, which is the product and capabilities team, where we basically build software. We also have a meetup group that meets almost every month. This is our, you can scan this QR code and join us on the StackX meetup, as well as our Telegram group. So you can also meet other people who are interested in finding out about what government is doing and the e-services that we're pushing out. And I think that's, and if you want to know more about how we in Govtech develop software, you can go check out developer.gov.sg. It documents our current thinking around how to build software and how the different methodologies that we follow and how we can get things done, and different technology stacks that we use. So if you're interested about the different tech stacks that Govtech uses, you can go check this out. That's all I have actually. Yep, that's all I have. Any questions? Again, you can find me at these places. You can, yeah. Okay. So how do I move from non-tech background to tech? So I started out in university studying history and political science and economics. And I got interested in building websites. So, part of me as a designer likes to build websites. So, so I started looking at how people build websites because I like to beautify things. So I kind of built a HTML site, and I work. And at the time I work, I also work because I knew how to design a website. I worked with a company that was building software for people. So, so essentially, I was always curious about how things are just put together. So I was asking myself, oh, how does this Yahoo search bar work? How does this login form work, right? So that whole curiosity about how things work basically got me thinking about how you can build things with just writing a few lines of code and at the time I really didn't know how to write software. I was just copy pasting things, searching online and finding blog posts and reading documentation. As it got into it, I was like, okay, I can actually build things because I kind of know how things are wired together. So I kind of figure out how does this thing link to this thing, so it's about drawing all these lines and it's fascinating. So it's like how in history and economy and political science, I try to cause and effect, and you think about input outputs. It's roughly the same, So, yeah. So that's essentially how I got into tech. Does that answer the question? I hope.
Yes, definitely. Thanks.
Okay. So to be honest, I actually don't have a degree in arts and social sciences. So I didn't actually graduate. So yeah, so to be brutally honest there. Yeah, so don't do what I do. Please don't do what I do. Get a proper education and get a degree or something. Yeah. I went the hard way. So Mr. Gee asked me about what's the difference between Singapore Power and Govtech. So before I worked in Govtech, I was at Singapore Power, and I think essentially I had always been working in the private sector. So joining Singapore Power was like my first corporate company that of that size I joined, and then eventually to Govtech. The difference I felt was government things do work a little bit slower, but government do a little bit slower, but as in the policy changes takes a bit longer to come through. And whereas in the private sector, usually you'll be much faster to implement things. That's one thing. But in the same time, we also try to, GovTech itself is very agile. We like to do things fast. We like to innovate, but it's also we try to also craft policies that help us be agile and build things fast. Like for example, we believe that cloud is an important technology to have, as in cloud services, and we wanted to have that in government. So how do you do that in government? So they draft up a policy about how we should do this, and how to get government software into the cloud, and they found out there's a way to do it. And what they did was they ring fence it and say this is the government cloud. And so government commercial cloud. So government commercial cloud, or GCC, is basically backed by commercial cloud. It's a on the front end is like the government login, but underneath it is AWS, Azure, or a Google Cloud Platform, which so they crafted policies that made it easier for us to do things and it's very in a way I'm very thankful that there are people who are forward thinking in government, and they're able to push for changes that could help us get to that point, which is very helpful. Yeah. Whereas in SP, they would move not as fast also, but yeah, but
Yes,
it's
waterfall versus agile. Yeah.
in a way, yes. But at the time when I was at SP, I was in a group called SP Digital, Singapore Power Digital. So essentially, it was, and it still is somehow the digital transformation arm of Singapore Power. And we actually built really good software there. For example, we use the SP Utilities app. It's actually an app that was built by the team that I was part of, and we're able to like get things out quite fast as well. I think in 6 months we were able to roll out the first version of the mobile app, and we had to work with a lot of legacy code. So even though we're agile, again, the same thing in Govtech, even though we're agile, we work with a bunch of folks who still run in very waterfall kind of way. So sometimes in order to compensate for that, you try to think ahead of them. As in you try to forecast, like, okay, I think we'll need this piece, and we need this piece, we need this piece. And then we talk to the folks in the other parts of the pond which uses waterfall methodologies, and you try to tell them, okay, I need this piece for integration, I need this piece for integration, I need this piece for integration, and you help them plan ahead, because you anticipate your needs in the future, and then they can help. Then they can work with you on that, right? So that's how you work in teams where that folks are still in the traditional waterfall kind of methodology, and agile teams. You basically help them move in a way that would not block you, I think. Yeah, any other questions? We have about 3 minutes. If there's no other questions, then thank you. I hope this was helpful. Cool.
Hi, thank you so much, Mr. Cheng, for the wonderful keynote and telling us all about Govtech, and also, I guess, a little bit about SP as well. So now we'll be having a 5-minute break from now until 9:13. So please come back by then for your workshop.
Okay, the time now is around 9:13, so let's start with the next activity, which is part 2 of your Dino AI workshop conducted by Isaac, Kingle, and Tuti from 9:13 to 10:25.
So today they're going to teach us how to make an AI to play the dinosaur game for us. So in the past few days, we have learned how AI can take over our pattern recognition, and then how we can create music using AI. And then now they're going to be playing our games. So basically, we are all going to be replaced.
Anyways, let's start.
Can you all see my screen? Am I sharing it?
Yes, you are.
All right. Hello, everybody. My name is Isaac, and I'll be one of the presenters for this workshop. The others will be Kingle and Sam, who will be coming later. So yesterday, there was a workshop about an introduction to evolutionary AI and NEAT, and this will be the continuation of that workshop, where we will be implementing the technologies that you've learned in theory into code. So in this case, what we'll be doing is we'll be using the dinosaur game. Google's dinosaur game, if you don't know, is the game that you can play when you lose connection and you try to. On cam, my cam is on. Oh wait, actually no, it's not. Okay, so what the dinosaur game is yeah, it's basically the game that you can access when you don't have an internet connection and you try to use Chrome. Yeah, so if you're not familiar with that, it's basically just a side-scrolling jumping game where obstacles are coming at you and you jump over the obstacles. So it's a dinosaur jumping over cactus. And first, in the first part of this workshop, we'll be implementing the game. And in the second part of the workshop, Kingo will give a brief recap on what a NEAT is And in the third part, Sam will be going through how to implement Neat in your game. So if y'all have read the prerequisites for the workshop, right? Have y'all installed the zip file? If not, the zip file is here. I've sent the link in the chat. After downloading and extracting it, you should have a BBCS folder in your downloads directory, and you can just open the folder in your preferred ID, your code editor of choice. So today we'll be editing game template.py for the game section. If you haven't already installed Neat and Pygame, which is the module that we'll be using for the game to build the game, you can just run install Python and pip install Pygame. Yeah, you should have already done this before the workshop as well, but just in case you haven't spent time setting up. Yeah, can go send it in the chat. So after y'all finish the installation, y'all can just open game template.py. Is everyone okay? Like, does anyone have any issues with the setup? Okay, it should be pretty straightforward. So let's get started. So first, we import Pygame. Our game will be built using Pygame, and all the objects in our game, which are like the dinosaur, the cactuses, and the obstacles, they will be represented by objects. They will be represented by classes in the game. So this is essential for when we are using Neat, because all your objects in the game have to be represented using classes. If not, Neat won't work. Yeah. So we call pygame.init here to initialize Pygame. And then here we set a bunch of constants like the screen height and width. So this is just the pixel height and width of the screen size of the game. So here we have a bunch of objects representing the running animation, the jumping animation, and the small cactuses and the large cactuses. So if you look here in assets, right? If you have assets in your template folder, yeah, you do. So if you look in assets, right, you can see a bunch of images like large cactus 1, 2, and 3, and dino jump, dino run 1 and 2. So these will be used. These will be shown on the game screen during the actual game. So in the case of running, right, you will have two images, dino run and dino run 1 and 2. So these two images are like, it's the same dinosaur, but then the feet is like different. So these two will alternate back and forth to give the illusion that the dinosaur is running. So it's an animation frame kind of thing. As for the small characters and large characters, these will just be a collection of the characters images. And what we'll do is every time we want to spawn an obstacle, we'll just pick a random one and show it on screen. And for this one, track.png, this will just be the background. So over here, if you want, you can zoom in close. It's just a line with particles on the bottom to represent the ground. And this is just the game font. Do we need to install the Python extension VS Code? It would be nice if you can, yeah. Turn on word wrap. So as you might have guessed, in the dinosaur game, a significant object in the game would be the dinosaur, right? So first, we want to define the dinosaur class. So we have a constructor here, def init, and we take in the parameter running at index 0. So running at index 0, right, is dino run 1, is the asset dino run 1, and this is going to be the default running position when the user first starts out the game. So it will start at dino run 1, and then it'll alternate. Dino run 1, it'll alternate between 1 and 2. So we have to define a couple of attributes here. First, we need to define this image as one of the attributes. So self.image equals the image. Next, we need to check if the dino is either running or jumping. We need to have states for when the dino is running or jumping, and these states will be Boolean. So self.dino jump and self.dino run. So when the user first starts up the game, or when the AI first attempts to play the game, the dinosaur will obviously be in the running state instead of the jumping state. So this dino_run, we set to true. And dino_jump will be set to false. Next, we need to specify parameters for the jump. So we will have a jump velocity. So we can define the jump velocity outside the init method, outside the constructor method, and we can do we can just name it jump velocity, and this will be set to 8.5. I think it's a very good number. This will just be how fast the initial velocity of the dinosaur in going up. So when you jump, right, you have a certain deceleration due to gravity. So your initial velocity will determine how fast you jump initially, and the gravity will determine how fast your velocity decrements. So every frame it will increment by this jump velocity, but at every increment, right, it will be a bit less. The increment will decrease, like the magnitude of increment will decrease because of the deceleration due to gravity. Yeah. So we can do self.jump velocity equals to self.jump velocity. Next, we'll need to define a bounding box in which the dinosaur is placed in the screen of the game. So it can be defined by self.right. So this will be the position that the dinosaur is in, and we'll called pygame dot method. And so this method takes in four parameters. The first two will be x and y coordinates. So these will be the x and y coordinates of the top left corner of the rectangle. And the last two parameters are the width and the height. So how long do you want to extend in either direction, downwards to the right? The reason why this is so is because when a computer generates like an image or renders an image, right? They render from top down. So they render from the top left-hand corner to the bottom right-hand corner. So x will be increasing from 0 to the image size from left to right. And for your y values, right, it increments from top to bottom instead of from bottom to top. So 0 will be at the top, and the y value representing your image height will actually be the y value at the bottommost pixel of your image. So in this case, we want our dinosaur to be slightly to the left of the image, but about in the middle. So if you who was that? Can you read yourself, please? Okay, but anyway, so if you remember, right, our screen height and width is 600 by 1100. So we can make our x position about 80. So this is about like the far left of the screen. And for our y position, make it about 310. And for our parameters here, it will just be self.x position, self.y position. And for the width and height, we can just take the width and height of this image over here. So image.getWidth and image.getHeight. So this will be the bounding box that will make it easier for you to see like the different kinds of the different dinosaurs when all of them are overlaid together when you're playing when the AI is playing the game, because at one iteration, right, there will be many dinosaurs at once playing the game, right? So in order to better distinguish between them, we can draw bounding boxes that are of different colors. So obviously we have to set the color as well. And we can't let all of the bounding boxes be the same color, because that won't help in distinguishing like each of the individual dinosaurs that are playing the game. So we'll do self.color. And we'll just set this to a random color. So we can just import random. And here we'll just randomize the color. So it will be a tuple, RGB, and each value is between 0 to 255. So what we can do is we can just random.ranin between 0 to 255 inclusive. And we can just repeat this for all three elements in the tuple. So this will just generate a random color. And lastly, we'll have step index. So what this is for, right, is it's for counting. Firstly, when you should alternate between Dino round 1 and 2, because you don't want to do it every frame. it's very distracting that way. So you want to do it about like every 5 updates or so that you can see the distinct steps that the dinosaur is taking, instead of the dinosaur just like being like some car engine or something. And another thing step index is used for is to calculate your score, because if I don't know if you played like the actual dinosaur game before, but it increments by like 100 every 10 steps you go. So it's like discrete. Okay, not that like normal counting isn't discrete, but it's like in discrete steps of 100. And so you need a way to know, when should I increment by 100, because it's not after every update. So it's after like every few updates. So you're gonna have to have a way to be able to calculate like the time in between each score increment. So we'll set this equal to 0 first. So next, we need to define an update method. And what this will do is this will do 2 things. First, it will check for these 2 booleans. And if one of them is true, then it will run the jump and run method respectively that we'll be defining down here. And secondly, it will also check the step index. So for step index, after every 10 steps, we'll be incrementing the score. And after every 5 steps, we'll be incrementing we'll be changing our assets. So lowest common denominator is 10. So we can just calculate for when the step index is greater than or equal to 10, which will mean that the step index has overstepped its bounds. So we can just reset it back to 0. So like after every 10 steps, after we've incremented the score, after we've done all the necessary updates for the Dino 1 and 2, then we'll just reset the index back to 0 so the cycle can repeat again. So first, we have to check these 2 booleans. So it's self.dino_run, self.run. And if self.dino_jump, self.jump. And if self.stepIndex is more than or equal to 0, we'll set it back to 0. So self.stepIndex equals to 0. Can't we use a mod function? You could totally use a mod function. I just don't see why that would be necessary, because step index, ideally you want to keep the number very small, so it's a bit more descriptive. So let's say your step index is 0 to 4. You will know, I'm on Dino Run 1, right? And let's say your step index 5 to 9. Oh, I'm Dino Run 2, right? So there really isn't a need for step index to go anywhere beyond that, because if you want to calculate like, what division of 5 is it, right? Because they're calculating multiples of 5, right? So 0 to 4 is 0 to 4. You will do you will have the Dino Run 1 asset. 5 to 9, you will have the Dino Run 2 asset. But this gets very difficult when you use the mod function, because let's say let's say you're on 4, right? Let's say you're on step index 4, and I want to have Dino Run 1, right? So 4 mod 5 is 4, right? But 9 mod 5 is also 4, but 9 at step index 9, you need to be rendering down around 2 instead of down around 1. So it's very non-descriptive in the sense that there's ambiguity when you use mod. So instead of using mod, right, what you actually have to do, right, is you have to do a division as well. You have to do a division, and you have to check whether division is even or odd before you can make a proper decision on, oh, which asset should I choose, right? So that's just a lot of work, right? If you can do this, then why not, right? Because doing the division at each step is just yeah. I mean, it's not that computationally heavy, right? But this is just a bit more convenient, I find, to implement in code. So we'll be defining the jump method. So we have self.image, and if you remember correctly, if at the start of the game's execution, the image will be set to running, right? So actually, at every step, if the dinosaur is running, it will be a running asset. So we need to set the image to a jumping asset instead. So we need to do self.image equals to jumping. There's only one jumping asset, so we don't need to access any index or anything. So next, we need to do a few things that are required when jumping. So when jumping, you need to have an initial velocity. Remember, we defined jump velocity here. And we also need to have a gravitational acceleration, right? So that when the dinosaur jumps, it will travel in a sort of parabola, two-dimensional, a one-dimensional parabola, instead of just moving up and moving down, like with the same speed constantly. That would just be very weird and very unnatural. Yeah. So to increase the realism of the dinosaur game, we'll implement gravitational deceleration. But first, we have to check if self.dino_jump is true. So dino_jump has another purpose. It's here to ensure that the dinosaur is moving upwards, right? No, the self.dinosaur jump is to ensure that you call this jump method correctly. So like even though we check here, right, I find that sometimes the jump method, when the jump method is called, self.dino jump is actually false. I'm not sure it's because of some sort of ordering or what, but yeah, best to check in this method as well. So if we are jumping, if dino jump is true, then we can start the jumping. So self.x.y. So this will be a reference to the earlier rec value that we had, and remember that this represents the location of the dinosaur on the screen. So what we want to do is we want this location to go up a few values of y, right? And when we go up, remember that the y value at the top is 0, and the y value at the bottom is going to be your image height. So to go up, right, we we actually have to decrement the value of y. We actually have to subtract a certain value from y. And this will be our jump velocity. This value will be our self.jump velocity. And 8.5 pixels is really not that much. So I find it's a lot better if you multiply this by a constant. So this constant in this case will be 4. Right? And of course, we need to have our deceleration as well. So at this spot, you will do self.jump velocity as equals to a constant, let's say 0.8. This will be our deceleration. So every time the jump method is called, it will move up by jump velocity amount of pixels times 4, and jump velocity will decrease. So every time it calls jump velocity will decrease, jump velocity will decrease, and so yeah, so that's how gravity works, right? After this, we will need to check whether the dinosaur has reached the ground. So once the dinosaur has reached the ground, you can safely say, oh, the dinosaur is running. He's no longer jumping. So the way we can do this, right, is we can do this by checking if this original jump velocity. So some of you may be wondering, how come I define jump velocity here and I also define jump velocity here? Like, why have two of the same thing, right? They're not the same thing. This one is a constant. That's why I define it outside the constructor method. But this one actually changes, right? The value of self.jump velocity in lowercase changes over time. And so we can use the original jump velocity to compare with the current jump velocity. So the way this works is that when you're moving in a parabola, right, with constant deceleration and an initial velocity, with no other external force, right? If you study kinematics, when the dinosaur reaches the ground, it is traveling at the same y level. It will be traveling at the same magnitude of velocity, just with a different direction. So let's say the dinosaur is traveling initially at a velocity of 8 kilometers per hour, right? 8 kilometers per hour in the to the sky, right? So in the direction of the sky, right? So it will jump, and gravitational deceleration will work its magic. And at the top, at the instant where the dinosaur reaches the top, the velocity will be 0, right? And when it starts decelerating from there, the velocity will start to have a different polarity, right? The velocity will start to be negative. And that is when the dinosaur starts traveling in the opposite direction. So it goes 8 kilometers per hour to 0 kilometers per hour, then it will experience the same gravitational deceleration downwards. And when you have the same deceleration downwards, right, as you did when you were going up, when you reach the same y value at which you initially had 8 kilometers per hour, right, you will be traveling at negative 8 kilometers per hour. Right, because you have the same gravitational deceleration over the same distance, right? Do you understand? If you don't understand, you can just ask questions in the chat. I'm sure my physics educated friends would be happy to guide you. But that's how it works. So anyway, you need to check if self-jump velocity is less than equal to negative of the constant jump velocity. Yeah, so that's the idea behind it. So negative equals to negative self.jump velocity, will mean that it has reached or it has surpassed the mark in which the y value that it was at originally. So you might be asking, oh, why don't you just check if the y position is less than or equal to 310, for example, right? Because our initial value was 310. Yeah, I just thought this was a more fun way of doing it, and we can go through kinematics in a lecture about evolutionary AI. So anyway, that's digressing. After we have safely landed on the ground, we can just resell our boolean. So Dino underscore jump, we can, that was Danny, we can set the false. Dino run, we can set the true. And because our jump velocity could have exceeded the threshold, the constant jump velocity, we need to reset the jump velocity. And also because it's of a negative polarity. Yeah. So self.jump velocity equals to self.the constant jump velocity. Maybe I should have named them different things, but too late to face that now. Right, but that's the jump method successfully defined. Now we'll need to move on to run. Run is a bit more straightforward. Run, we just have to alternate between the different assets and increment our step index. Yeah, so self.image, you need to set that to an asset in the running array. And how we will access this index is we'll just do a quick floor division. So self.step index, and we'll do a floor division by 5. So what this does is it will result in, because since our self-step index is limited to from 0 to 9, right? What this will do is this will check, oh, am I at 0 to 4 or am I at 5 to 9? Because when I'm at 0 to 4, this value will be 0, right? If you don't know what floor division is, it just divides by this number and it takes away all the values after the point, after the decimal point. So it will just be an integer value. So let's say 2 floor divided by 5 is 0, whereas something like 6 floor divided by 2, if 6 floor divided by 5 would be 1, right? Because 6 divided by 5 is 1 point something something, and 2 divided by 5 is 0 point something something. So that's how floor division works in Python. And since we are ranging from value 0 to 9, from 0 to 4, we want to access index 0, which is Dino run 1. And for 5 to 9, we want to access Dino run 2, which is which is the other asset. So this will alternate assets every 5 steps, which will result in a much more smoother, pleasing to the eye animation, rather than just spamming the changes. Next, what we want to do is we need to reset our x and y position. So self.rec.x equals to self.x position. And we do the same for y. This is just to prevent the dinosaur from moving away from its intended position. You might be asking, why don't we like increment the x value, right? Because it's running. That's not how the game works. So what the game does, right, is it's the dinosaur is in a constant place, right? The dinosaur position doesn't change. The dinosaur X position doesn't change. Instead, right, it's the background that's moving behind it, right? So we don't need to do any X increment or anything. But lastly, we have to increment the step index. That's something we do have to do. So plus equals to 1. Right, but we haven't actually done anything on the screen, right? So if you can think of it as like, if you know Git, like git add, then git commit, right? We haven't actually committed anything to the screen. Like we told the machine, oh, do this. We haven't actually said, oh, put it to the screen. So this draw method, we can call split method, so screen.split. And what this will do is it will say, oh, using this image at this particular X and Y coordinate, right? Bam, I will now show the image on the screen. So this is just very simple. This is self.image and a tuple with the X and the Y value. So this can be done by just accessing the X and Y attributes of rect.x and self.rect.y. And yeah, that's all we need to do for the dinosaur class. So the class has been fully defined. Now we will move on to our obstacles, which are a bit simpler. Yeah. So for obstacle in our constructor, we need to define only 4 attributes: self.image, of course, self.type. Self.type will be how many cacti you want to spawn in. So if you recall, in assets, you have a few assets for the cacti, and it goes 1, 2, 3, right? So you have 1, 2, or 3 cacti. And every time you spawn an obstacle, you'll need to generate one of these obstacles randomly. And having a variety of cacti will increase the game's excitement factor, I guess. If different obstacles coming at you if the different number of cacti coming at you is anything much of a change. So self-type equals to number of cacti. This is one of the parameters of our constructor method. And here we'll also have a self.rect. And this will be self.image. And we need to access the type, of course, because self.image will be either small cactus or large cactus. And these are arrays with the index 0, 1, and 2 representing the cactus 1, 2, and 3 respectively. So we'll need to access self.type index of self.image. And we can just call the get_rect method. So this will be, yeah, this will just define the dimension of the rectangle for us. And we can set self.rect.x because this just gets the width and the height, right? There's no way that we can tell where do you want to place the obstacle, right? If you just specify the image. So we can specify either the X or Y coordinate of the rectangle. So the rect.x we can specify as the screen width underscore width, because it will be coming from the rightmost part of the screen, right? So that's where we want to place it initially. So as for the Y value, right? The Y value, since it's the from the top left, right? Since it's the top, it defines the top left of the image of the rectangle. It will vary between small characters and large characters because small characters is small and large characters are large cacti, are large, right? And when you have this difference in size, the Y value will obviously be different because you want them to be sprouting from the same Y level on the ground, right? And so the small characters Y value would be slightly greater as compared to the large characters value. So you might be wondering, oh, shouldn't small characters be smaller? Yeah, but earlier on I did mention that 0 was the top and your max Y value will be at the bottom, right? So when small characters is situated lower than large characters, small characters will actually have a higher top left Y corner as compared to the large characters. So yeah. Self-directed X will always be the screen width. That won't change no matter what characters you spawn in. And you have an update method, so self.rect.x, and we'll subtract game speed. So game speed will be a little constant representing the speed at which the game runs, obviously, if that wasn't obvious from game speed. And so it will decrement by game speed every time the screen updates. So it will move closer and closer towards the dinosaur. And lastly, what we want to do is you want to detect whether obstacles have exited the screen. That means they have already passed the dinosaur and there's no need for them anymore. So if there's no need for them anymore, what you want to do is you want to despawn the object, right? Because you don't want the object to continue carrying along forever. So if self.rect.x is less than negative self.rect.width, what you want to do is you want to pop the obstacle from this array of obstacles. So this will be another thing that will be defined in the later half of this workshop called obstacles. Pop. And yeah, that'll be it. So it might say like obstacles and game speed are not defined. We'll be defining this later in the workshop. So yeah, just follow along. So draw is the same thing as before, screen lit and self.image, and we have to access self.height. And for the tool that represents the height and the width, all we have to call is self.rect, yeah. So we have two more class definitions, small characters and large characters. These will inherit from obstacle. That means these will have all the attributes if you provide it, and methods of the obstacle class. So by inheriting from obstacle, right, the small characters will by default have the update method and the draw method already defined, so we don't have to redefine the method unless we need to like overload or something, unless we need to redefine those methods. So that's the wrong thing. So in the constructor, right, of these two classes, since we have all the methods defined, we don't really need to define any more methods. But what we do need to do is we need to set different Y values, right? Because as I said earlier, because of the height difference and everything. So what we can do is we can call the init method of super. So what this does, right, is this will look at the init constructor of the parent class and of the super class, so which is obstacle, which is the class that small characters is inheriting from, and it will use like the parameters here to define the attributes here, right? So it basically like constructs everything for you, so you don't have to like copy and paste this chunk of code into here. So here we can pass an image and the number of cacti, like the parameters that we are accepting. And what we'll do is we'll define a y value, right? So self-correct y, and we'll set it 0 to 300. So 300 is a good value because if you set the top left hand, if you set the top y value to 300, when you reach the ground, right? When you reach the bottom of the image, bottom of the cactus asset, the bottom will be just nice on the ground. Yeah. So for large cactus as well, you can call the same method. And in this case, we can wait for small cactus, we set it to 325. Sorry. For small cactus, we set it to 325. And for large cactus, we set it to 300. Because small cactus has to be greater than large cactus. Right, so once that's done, the game is actually just about complete. And so the game definition and everything is just about complete. So I'm gonna give you a few seconds to like consolidate. Right, so now, right, what we actually need to do is we need to run the game because this is not complete. This is just like the class definitions and everything for all of the objects in our game. So we need to continue by defining a main function, which will be executed. So it'll run our game up. So firstly, what we need to do is we'll need to define a remove function. Def remove at index. And what we need to do is we need to. So when need is running, right? I'm not sure if you remember from yesterday's workshop, but if you don't, there are a bunch of dinosaurs playing the game at one time, right? And so you will have an array with all these dinosaur objects. So when a dinosaur dies, right, we need to remove it from the array. So what we need to do is we'll have an array called dinosaurs, and we'll just pop the dinosaur out of the array. So dinosaurs pop at index. Oops. Yeah. So next we'll define a main function. And this will be where the game is run. And we can just put a call to main at the end while we're at it. So as I said, obstacles, dinosaurs, game speed, all that, these will be global variables. So we can define them in main. So global game underscore speed, obstacles, dinosaurs. Global is just global just enables all these variables, right, to be accessed in the global stack. So you can just access it from anywhere, including like inside methods and stuff like that. Yeah. Outside the stack at which you define like the variables. Yeah. Besides obstacles, dinosaurs, and game speed, we also need a few other global variables. So we need the background X position and the Y background X position. So Y underscore position underscore PG. And we also need to calculate the point, right? So that will be another one of our global variables. We also need a clock. So clock equals to plugin provides a clock, so we can just initialize one using the pygame.time.clock method. And we'll need to define our points. So we'll assign a value of 0 to points. Points equals to 0 at the start. And we need to initialize our dinosaur array as well. So dinosaurs equals to an array, and inside the array we can just put a dinosaur object. So dinosaur, and with the curly braces. So this will be a dinosaur object. For obstacles, this key will be empty when we initially define it. So obstacles equals to empty array. And for the background, we'll need to specify its X and Y position. So this will be 0, and for Y, it will be 380. Earlier on, when we defined the dinosaur to be at 310, so our background has to be a bit greater than this Y position, right? So that it will appear lower on the screen. And we have to set the game speed as well. This will be 20, right? The game speed, right? It will start off slow, but as the game is running, right, as you get more and more points, obviously, you have to have some form of challenge to keep the player entertained, and so that they don't like rack up an insane score. You need to increase the game speed to increase the difficulty of the game, like with every increment in score. So first, we need to calculate the score, right? So find score. This function is defined in the main function. So we'll have 2 more globals, points, and game underscore speed. Game underscore speed was already defined. These will be accessing the global variables that we defined here. So we can just increment points by 1. Right, and then we need to check whether we need to increment game speed. So if points mod 100, so we'll be incrementing the points by 1, and then after every 100 increase in points, because it in the original game, right, it increments by 100 each time. You will increment your game speed by 1 as well. Game speed can't be, you cannot increment game speed by too much, because game speed will be called every time the characters moves forward. So when a character moves forward, right, you move forward by game speed amount of pixels, right? And you can imagine that this is like integral. So if you increment by 1, right, if you increment game speed by 1, right, if the character moves forward like 7 times, right, that will be an increment of 7 already, like 7 pixels greater towards the player with the same number of updates. And so yeah, be careful with this value. If you want the game speed to increment a bit faster, I'll recommend like something like something like a decimal point. Then you check, then you convert it to an integer over here when you mass equals the game speed. But I wouldn't recommend anything greater than 1 because I think this is a pretty good value. Anyway, that's going off point. So we need to display the points on the screen, obviously. So font.render, x equals to font.render, and we can just put points equals to, and we can make an f string so that we can put our variables inside it. So string points. So next, we'll set it to true, meaning that it will be displayed on screen, and we need to set the color, which will be black. So 0, 0, 0. And remember, we haven't committed it to the screen. This is just a variable floating around in memory. So what we need to do is we need to call screen.lit, the text, and the location. So this will be 95050. So this is finally this is all the way to the right of the screen and very close to the top. So that's where the points are normally shown in the actual game, right? So that's that's why we will show the points here. Next, we'll define the background. Def background. So we need to access the globals x plus background and y plus background. So first, we need the width of the image. So image width equals to bg, which we define all the way up here. This is our track asset. And we'll do bg dot get width, get underscore width. Right? And since we need to split this the screen, so we'll call screen.lit bg and x underscore position underscore bg, y underscore position dot bg, and we'll need to put another image, and this time we add the image width to x pos bg. So this will render another image that will follow to the right of the current background. So this will enable the background to like encapsulate the whole screen, even if it's like continuing to the right. So if next we need to check if x underscore position underscore background is less than or equal to negative image underscore width, and this will mean that it's already exiting from the screen. So we set this variable back to 0. And then we can just decrement this by the game speed. So after this, we'll set run equals to true, meaning that we'll be running our game. So while run, we'll listen for events. So for event in pygame.event chat. So this will just be a listener for stuff like quit. If the user wants to quit, if the user wants to if the user wants to quit at any time, he can just press the key and it'll quit. Yeah, so if event type dot type is a game dot quit, then I will exit the game and I will do a sys.exit as well to close the application. So here we need to import sys as well. Right. So after that, we need to have a white background. So screen.fill, and this will be a tuple 255 255 255. So this will be white. And we want to update each dinosaur. So for dinosaur in dinosaurs, dinosaur.update and dinosaur.draw. And we'll pass in the value to the screen. So this will update and draw the dinosaurs to the screen. If there are no more dinosaurs, we'll break and move on to the next loop. Zero, break. If there are no more obstacles, then we have to add more obstacles. So if length of obstacles equals to 0, then we will generate a random integer from 0 to 1, denoting whether we want to pick a small cactus or a large cactus. Random_in equals to random.randin 0 to 1. And so if randin equals to 0, we'll append a small cactus object. So small cactus, and we'll pass in the small cactus image array, random.randin 0 to 2 to denote how many cacti we should spawn. And it's the same thing for large cactus as well. Just that we have to define, because of that we have to pass in a different asset array. The random array is the same. So lastly, what we haven't done is we haven't lit the obstacles to the screen. So for obstacle in obstacles, obstacle.draw screen and obstacle.update. Now we need to check whether the dinosaur has collided with the obstacle. So for I, dinosaur in enumerate dinosaurs. So this enumerate will just return the index, both the index and the value. So we can iterate through both the index and the value of the dinosaur array. So if dinosaur.rect, we can access the position of the dinosaur, and we see if it is collided with the obstacle with a collide rect, and we pass in obstacle.rect. And then if as so, we will remove the dinosaur index I. Lastly, we need to make the dinosaur jump with every press of your space bar. So user_input equals to pygame.e.getPressed. Right. So we iterate through the dinosaurs again. And this time we do if user underscore input pygame.a_space. Then dinosaur dino jump. Jump. We set the true, and run will be set false. Lastly, we can call all the functions that we defined. So score, background, clock.pick 30, and pygame.display. Yeah, so that's the whole game code done. Now I will pass the time on to Sam, who will go through how to implement it into this game.
Hello. Okay. Can you see my screen?
Yeah.
Okay. All right. So due to because of time constraint, I'm just gonna be like going through like just roughly what's going on. So first we have this config file, which is what you need to run the neat neat library. So I'll just be going through the important ones because most of these are set in the default value. So first we have the fitness criterion. This is basically how you select the dinosaurs for the next generation. So if it's set to max, you would choose the highest fitness score, the dinosaurs with the highest fitness score. And then the fitness threshold is the value of the threshold is that once a dinosaur that has reached this much fitness score, it is considered that we have found a solution. And then the population side is how many dinosaurs that will be running per generation. So here we set it 20. So you can just like change the value, you can increase it if you have a good CPU, stuff like that. And then the next thing is the activation function. We're using hyperbolic tangent here, but you can really just use anything you want. Just try out. Some give better results than others. So yeah. And then the next important thing is the network parameters. We are using two inputs. One is the y coordinate of the dinosaurs, and the second one would be the distance between the dinosaur and the obstacles. And the output is just one output because it's the action is either to jump or not jump. We don't have any hidden layers, but you can try to experiment with hidden layers if you feel like it, right? So let's go to the code. This is the exact same code that Isaac just programmed just now. So first we want to delete this, and we'll set up the we'll set up the neat function, the neat algorithm using this. So what this does is basically sets up, it loads everything from the config file into, it just prepares it. And then, so this line prepares the population, and then it runs this eval genome, which is something that we'll be modifying later on. It runs it 50 times. Yeah. And then next we'll be including this if statement, where it just runs the whole thing. Okay. So next we'll be modifying the main functions to we will be changing it into eval genome. So but this eval genome will take two parameters, which is genomes and config. And then now we'll be just deleting this dinosaur object that we created because we won't need it. And then we'll make two new lists. G, which stands for genome. This is a list of dictionaries that stores each genome of like the dinosaurs, and then the neural nets, their fitness score, etc., etc. And the nets is just the neural network of the dinosaurs, right? Okay, what else? So now we'll be running so now we'll include a for loop here. So this loops through this loop through the stuff in the genomes, and so for every genome you will add like a dinosaur object to the list, and you also configure a net and add it to the nets. So at the start we'll have every dinosaur will have a fitness score of 0, and as it does things, we'll change that. Yeah. Okay, what's next? So I think I'm gonna stop here. Right. So we want our dinosaurs to get as far as possible. So here is the code responsible for the collision between the dinosaur and the obstacles. So what we want to do here is that if the dinosaur collide with the obstacle, we'll have its fitness score minus -1, so that we don't want this genome to be passed down in future generations because they're bad. And we also can delete this because the game is basically going to play itself. Okay, what else? Okay, now this is we don't need all of these anymore. So instead of that, we'll be including this. So what this does is that we'll have the output, which is first the y coordinate of the dinosaur and the distance between the obstacle and the dinosaur. This discrete function will be defining later. And then if the output is more than 0.5 and the dinosaur is not jumping at the moment, the dinosaur will jump, and yeah, that's what it does. So now we'll be doing this distance function. Yeah, so this is pretty straightforward. You have a position of the dinosaur, position of the obstacle, and then you just finds out the difference. Yeah. Oh yeah, I forgot. So first, you also want to import math. And then here, we also want to remove the. So once a dinosaur collide with a obstacle, you want to remove remove its genome and remove its neural nets. So yeah, just what else? I think that's about it. Right. Let's try and run this. Didn't miss out anything. Yes, it runs by itself, but forgot to loop through this. Oh yeah, I forgot to include the.
So we can't see the plugin window unless you share it.
Oh, right. Now I need to include these two, G and nets, into the global variables. Now let's see where this runs. Okay, I'm gonna share my full screen. All right. Okay. So now you can see the game is playing itself. These are all generation by the neural net. So you can see this is the first generation, and they're already doing quite well. But as the game is like going faster and faster, as the longer it goes on, there will be some point where these would just like not be able to do the job, and yeah, you just keep going like this, and yeah, that's the basic gist of this. And then do I have time to like talk about the visualization of these data? Do I have time to?
Do we?
Yeah,
Do
we
we
have time.
We have time. Okay. So you know, this is nice, but what's nicer is what if we can like visualize this data, like how many dinosaurs are alive, how many dinosaurs, which generation is this, stuff like that. So to do this, we'll just have a. So I'll be doing the I'll be doing a hitbox of every dinosaur so that we can differentiate which dinosaur is which. And then we also draw a line from the dinosaur to the obstacles so that, you know, so that it is cleaner. And then we also have a small dashboard that displays the information on these dinosaurs. First, what we want to do is we will have give me a second. Right. I think yeah, so first we want to have the statistics. So let's define a statistics. Yeah, where do I put it? So what this does is basically it just displays how many dinosaurs are alive and what generation is this, and then what's the game speed. So we use Pygame to display all these three tags on these coordinates. So when we run it, it doesn't do anything because I didn't save. Okay, now wait, I forgot to run it. So, oops. So now you can see down here, you can see the how many dinosaurs are alive, what's the game speed, etc., etc. Yeah. And okay, what's next? The next thing that we need to do is the rectangles, right? The rectangles. So we need to go back to the dinosaur function in the draw, under the draw function. Yeah, this. So what this does is you just draw a rectangle around the dinosaurs. So all these parameters, this is where you want to draw it. This is the color, and then these are the coordinates of the dinosaurs. And this too is basically the pixel of the lines of the rectangle. And then we already have the, I think Isaac already set the color here, right? So yeah, this is the color that we'll be using for every dinosaur basically. And then for the last thing is the line connecting the dinosaurs to the obstacles. For this, we just do like a simple for loop where we just iterate through every dinosaur. Yeah, so this will loop through every obstacle, and then you will draw a line between the dinosaurs and the obstacles. Every dinosaur and every obstacle. So these two numbers are just so that the line starts at the center of the dinosaur, and yeah, that's what it does. Let's see how it runs. So yeah, you can see now this is way better. It looks way cleaner, and you actually get to see how the dinosaurs are doing. Yeah, that's about it. Sorry, it's a little rushed, because time. And if you need any help, you can always refer to the main.py here, which has everything in it, and it's also commented, so you know what's going on. Yeah. Is there any question? Okay, no, great. Yeah, I think that's it from me.
All right, thank you so much for the to the presenters. I would like to add a lame joke here, but we are really overrunning, so we'll just continue with the next portion, which will be the final stretch. So this will be a 7-hour journey. You'll have all the time you can have, not really all the time, but 7 hours to finish on your deliverables for today. So a quick reminder is that, Steve, would you like to explain this part?
Yep, sure. All right, so as I mentioned earlier this morning, you guys have to submit your final submission by 2359 today. So that includes your prototype as well as your pitch video. And then tomorrow, do check Discord in order to vote on other people's projects so we can find out who has the best one. And then we will release all the awards and give you all the prizes on Sunday by 2359.
All right, so again, the breakdown for the points. Today, you'll be submitting the pitch video, which is worth 400 points, prototype, which is worth 800 points, and the bonus 200 points for if you use AI bricks. Remember that is optional. And as well as that, there's also the optional 2 games and 2 trivias, which are all worth 400 points each. In total, you can get 3,800 points.
Now, in order to submit and get your points, you gotta create a GitHub repository and put your slides and your documents as well as your code there, but do leave out the video because the video can't go on GitHub because it's too big. So we'll give you other instructions for the video. I think you would submit it into a Google Forms instead. Anyways, just go to this forms, this link right here, go.buildingblocks.sg/submit, and the instructions should be there for you to do your submission.
All right, so now we have a quick reminder of the rubrics for prototype. It's 200 points for function, improvement, and design, as well as the extra points for AI bricks. And feasibility and intention are both worth 100 points each.
Now for pitch video, you'll be judged on 4 criteria. It will be persuasiveness, so how well you can convince us that your project is very good. And then afterwards, you have the introduction, which is a compelling hook, and then your presentation of the idea, so how well you enunciate, stuff like that. And finally, your interaction.
Right, so here are the optional activities as mentioned. There will be 4 activities, 2 games and 2 trivias. So for the trivia quiz, it will be released on Cosmology. If you have not joined that yet, the link will be sent to the chat. It will be released at this time and it will be strictly cut off by the end time. So do take note of the time if you want to submit it. It will be based on, okay, the trivia briefing will be given later. And then for the games, it's also, you have to come back to the main room for the briefing. We will announce 5 minutes before the start of the games for you to come back to the main room for the briefing.
Now, the trivia quizzes are going to be about previous workshops or AI in general. And as Jun Hong has mentioned, they'll take place on Cosmology. So go to this link right here, same link as before, but /Cosmology instead. Rank 1, 2 will receive 400 points, rank 3 and 5, 200 points, and rank 6 to 10, for 100 points. Tiebreakers will be decided based on how early you submitted. So do make sure you submit it as soon as possible and don't wait until the last minute. We will, as Jun has mentioned, we will announce the games 5 minutes before they start and do attend the briefing for the game so you know what's going on. Those will be held in the main room. And yeah, so I wish you the best of luck and I'll see you at, I think, 1:55 p.m. for the first game.
Oh yeah. And it will end at 5:40 because now it's 10:40. And the breakout rooms should open now. Do give us a bit of time while we open the breakout rooms. Okay, there's a bit of technical difficulties ongoing, so the breakout rooms will be assigned pretty soon, but just so you know that we will be giving you the full 7 hours, so no matter what time the breakout rooms open, you have the full 7 hours to complete it.
Yep. Do manage your time wisely, like lunchtime and break, stuff like that, to keep yourself energized.
Mm-hmm. Do remember that the submission is due by 2359 tonight, and not at the end of this session. So if you, at the end of today's event, if you still are not finished, you can continue on with it after the event. If you have any questions on what you need to submit, as well as any other things that you might have, any other questions that you may have, feel free to put it in the chat now so that we can clarify.
Jun Hong, I think it's time to pull out the elevator music.
All right. Yes.
Yeah, that's my jam.
All right, the breakout rooms are open for those who are still yet to be unassigned. Just wait a bit, we will assign you pretty soon. And you have until 5:44 to finish this session.
Let's move on to your next presentation, which is
Classdo. We have invited Classdo to encourage you guys to continue to pursue your interest in computing. Now, what is Classdo? It's a startup which focuses on offering educators and business clients custom-branded virtual collaboration rooms.
Today, BuildingBloCS has invited Emily and Zenon, who are interns at Classdo and also former Daman High School students, to come and share with us more about Classdo. So without further ado, we shall let them take it away.
Hello, can you guys hear me? Hello?
Yes.
Yep, we can.
Okay. I'm actually doing a screen share right now. I believe you should be able to see it on your screen. And
yep, we can.
This is actually the custom interface. I have turned off the video for this one because we already have our video over here. So yeah, shall we begin? So I thank the host for actually introducing us previously. I'm Zinan. And Emily, I believe is, yeah, okay. So yeah, we'll start with Emily.
And I was a former Daman High student and I took Page 2 Computing. So I'll be going for NUS for undergraduate studies, and I have interned at Classdo since April 2020. So I'll be quite excited to share with all of you. And
I'm just like a DHS Infocom Club member, and I'm currently reading engineering. So shall we begin? So I believe that the host actually introduced a bit about Classdo just now, but we are just going to go a bit more into the overview. Maybe Emily, you want to start first?
Yeah, sure. So basically for Classdo, it's more focused towards the edutech sphere, where we help to where we have not just video conferencing tools, but very powerful online collaborative features that allows both teachers and students to transition very well to online learning. So that's my opinion about Classdo. What about you, Zenon?
I think what you said was actually very true, and there are actually a lot of tools, right, that you can't actually find in other, like for example in Zoom. So for example, we are actually changing the slides back and forth right now between me and Emily. So we can actually do this. We can actually do this on our own, on our end without having to actually wait for each other to change the page on our own side, so we can actually see everyone synchronized. And there are also a lot of like useful features such as like, you know, recording to the cloud. So you actually don't have to like send the recording after a meeting. And there's just a lot of these small tools that all together, right, combine to make Classdo a much better experience. At least that's what I think. So I think if we move on to the next slide, why don't we start with our internship experience? So I've been doing interning at Classdo since I graduated from Diamond High. That was actually in 2019, and I've actually been doing it for around a year now. And for Emily, right? She just graduated and she's been with us for a few months already, and we are both interns together with actually. I'm not sure if he's here today. Joel is also here, and also some of my classmates who is actually Ling Shan and Ge Hui. So for Ling Shan, right? I think some of you might know her. She's also from computing, and basically we are just like we are just interning in Classdo as you know, learning as well as helping out with tasks. So Emily, maybe you want to talk more in depth into it. Anything you want to elaborate?
So, basically, like you can see in this picture that Classdo has quite a few interns, and I think what makes interning in Classdo very fruitful and fun is that it's basically quite open, and as long as you are willing to learn and willing to pick up new things, I believe that you will be able to learn a lot of stuff, which basically I also experienced it. Like initially when I just joined, I wasn't that strong in programming, but I guess like working on a lot of the things in Classdo made me learn a lot about different frameworks and just software development in general.
Later on, we'll actually go more into the culture as well. So for now though, let's just talk about some of the cool stuff that we actually use in Classdo. So we actually have a very effective teamwork tool, which is called Clubhouse. It's an app that we use in order to organize tasks between team members. And for me, I actually feel that this is something that I really appreciate, because many a times when group projects, when there's a group project taking place, you might find it hard to organize work between people, to share work between people. And this is just something that I really like about Classdo.
Yeah, I guess I share similar opinions. Like this was my first time working on like very large projects. And initially most of the stuff that I did were just like very individual and small projects. So like previously I never really thought that much about project management. But during my time in Classdo, I have learned a lot about like how it is important to actually prioritize different tasks and basically to manage expectations, because in startups or in any other projects that you're doing, you're bound to have like a never-ending list of nice to have features that you will want to include, but you also need to consider that it also takes the opportunity cost of time and resources, which is why it's very important to have a very good project management team to help you like guide you through the flow of the entire development process and to ensure that you are constantly up to pace. That's all.
Emily, you want to start with some culture? Yeah.
So these are the three cultures that these are the 3 points that both of us feel very strongly about in terms of the experience that we have in Classdo. So first, keep an open mind to learn new things, especially in like the field of technology. There's always a lot of like different programming frameworks, different new tools that keeps popping up. For example, like if you just look at machine learning research, every few days there are new research that comes like that gets published. So it's always like a constant, it's always very hard to try to like keep yourself up to speed. But I guess if you keep an open mind and maintain a positive learning attitude, it will be very helpful to like help you learn many new things. And second, do not be afraid to seek help. I think what is very important is that we need to know that every one of us have different strengths. For example, I'm not that good in terms of like design and implementing like front-end frameworks, which Xenon is actually very strong at. And also like the other interns have also helped to review each other's code and to provide very valuable feedback that helped in our learning. So maybe I will leave the third point to Xenon.
Yeah, so the third point is actually mutual respect and have fun. And I think it's something that is very strong, especially in startups. And it is really the kind of no, like there's no hierarchy between like each of us, and we are really just you know, on like kind of the same level, and we can actually suggest stuff for each other, and we don't actually have to worry about the kind of, you know, manager and like employee relationship that can actually make it a lot harder for the development to continue. I think if I go back to point number 1 and 2 shared by Emily, so basically keeping an open mind to learn new things is something that I really share the sentiment with, because when I first graduated from Dunman High, most of the technologies that we use in Classdo is actually something that's not very familiar to me. And as time goes on, I actually kind of got familiarized with it, and I understand why we are doing things one way or another. And actually, I gain a lot from it, and not just in terms of programming, but also in talking with people, in how to improve a product. And of course, do not be afraid to seek help is something that I think all of us should actually take away from. And just like hours ago, right, there was something very difficult that I really didn't know how to do, and I just asked Emily for it. And like this kind of like relationship between each of us actually makes it a lot easier for us to learn as well as to develop. And this is something that you should actually take away from no matter what you do. So I guess we'll move on, Emily.
Yeah, sure.
think the next one. You want to share the next one?
Okay. So for the next slide, we'll be sharing about some points that we took away from the internship. And basically there are three main things. One, time management. Two, managing our expectations. And three, staying focused. For the first point, I guess time management is definitely very important. For example, like let's say Zenon is also working in Classdo as well as doing his university at the same time. So it's definitely like quite a chore to manage. It definitely pays off to manage your time well, because when you're doing like development work or programming, most of the time you end up like spending too much time on certain features, and then you end up pushing back the tasks that you assign to for the current week. For example, I also experienced this myself many times where I got too caught up with one thing and I left like the other features ignored, and just I keep pushing them back to the next week and so forth. And so that is actually
it's definitely
kind
something that I agree with, because there are a lot of tasks is actually very time sensitive as well. So let's say if like this client asks for this feature, we do have a responsibility to answer to the client when we can actually finish it. And managing expectations, which is point number 2, is really something that is really important as well. So maybe we move on to point number 3. So staying focused is something that I think is something that lies something which is very important in all kinds of stuff, but especially in a team settings where you actually have to bear the responsibility of finishing something and then passing over the task to someone else for another stage of the process. And if you do not stay focused enough in order to finish your task in time, it can actually block someone from accomplishing what they need to do as well. So maybe Emily, you want to elaborate more?
So I guess like these 3 points also ties back very closely with our earlier slide about project management, where it's very important to have like transparency in terms of your current progress in the task, as well as probably like whether you need any further support or help from other people to guide you to like move forward. And so although these 3 points sounds like very hard to achieve, I guess if you put in enough effort, like you should be able to manage your time well, actually.
So I guess we will now talk more into what we do in Classdo. So for me, what I kind of do a lot of times is actually marketing stuff. So for example, promotional material. We actually make these video tutorials that we uploaded to YouTube as well. And in fact, I believe Joel, right, was actually involved in making the video marketing video for the company, and he really did a very good job. And you can actually go and take a look at it right now. So as for tech support, maybe Emily, you want to talk something about it?
Basically, initially when I first joined Classdo, I was largely doing tech support. Initially, I didn't really think that tech support was very important, but slowly as I started to do more tech support, I realized that clients are one of our like biggest testers of the system. Like sometimes they will tell you some bugs that they unfortunately encountered, or at other times they might provide you very valuable feedback about how you can improve the product based on their experiences. And so I guess like tech support is a very critical part of any product, because the product doesn't just revolve around what you want to include in the product and what you expect to see in the product, because the product largely sustains itself based on demand from the user. So you also need to keep a very open mind to users' feedback, as well as the problems that they might be facing. And so in fact, I think tech support is one of the most valuable part in any products. What do you think, Zilan?
For me, right, I actually find it find that this kind of like relationship between Classdo and the client, right, is something that that we take pride for, and it's something that our clients really appreciate. You can see that they are sometimes pleasantly surprised by the kind of support that we give our user, and I think it is something that at Classdo that I really cherish as well, because a lot of times companies don't give that kind of like attention to the customer, and I think it's something that Classdo does very well. Of course, I think if we move on, of course we are also doing some coding stuff. I think Emily, you want to talk something about computing, about coding, about the programming.
Yeah, so basically in Classdo, we do some development work. For example, as you can see on the slide, fixing bugs, making new features, and learning new technologies. And all of these are just part and parcel of any like software development work. And during the process, you actually get to learn a lot of different things. Like for every new task that you're assigned to, sometimes it may build upon your experiences with previous tasks, but at other times it might be something that is entirely new to you and is some part of the code base that you have never touched before, which really throws you into a position that allows you to learn the most. And usually, like in most software development companies, after you made some code, you will usually pass it to a peer, such as an intern for review. And during the review process, the reviewer will usually like suggest some points that you can change within the code. For example, how you can make something run more efficiently, and how you can align your code to the style guide, etc., which I guess also helps you like learn a lot along the way. And Zina?
Nothing really to add on. Maybe we want to move on.
Okay. And so this slide actually like shows some of the things that we use in Classdo, ranging from the infrastructure, front end, back end, and testing. So actually, like as you can see on the bottom part, there's this component called testing. And initially, when I was just doing my own projects, I didn't really do any testing, but I realized that testing is actually very important to also help you to also maintain some form of quality assurance in the code that you do. For example, like rec suit at the bottom, the third point, I believe it's a testing tool that helps to compare changes between different snapshots. For example, if I have some website, originally I would take a screenshot of it first, so-called a snapshot. And after making some changes, and I push the changes to, like, for example, GitHub, it will run the tests and compare the current snapshot with the original snapshot. And it allows you to like find out about certain visual differences between the components, which might help you like identify any unintended changes that you might have. What about you, Zinu?
I think it is actually something that I was actually not very familiar with as well. But it's something that I really, really appreciate because it actually helped me catch a lot of mistakes that I made. And I'll actually make those changes before I pass it on to someone else for review. I think if you see the other stuff, you can also see of course, we use a lot of tools in order for us to work together. So, for example, GitHub in order for us to share code base, and we actually use something called Vue for the front end, and you can also see the other technologies that we use for the back end. And yeah, I think let's move on. So this is actually something that is which is more general, I guess. So maybe I should start first to talk about tech. As all of us know, physical meetings are actually something that is not very possible right now because of the entire pandemic. And I think that technology has actually come into play a lot in the past year in terms of allowing people to continue working together in order for people to continue studying. For example, I think both of us encountered a lot of times when we actually cannot go to school physically, and as well as connecting to people, chatting with people. A lot of times you cannot go out with a large group of people, and I think that technology such as Classdo, right, is actually making a huge difference in terms of how in terms of how we communicate with people. And I think that this change, right, will actually continue even after the lockdown has ended, after the pandemic has ended, because I believe that a lot of schools, a lot of tuition centers actually found that it is actually much easier for lessons to take place online. And a lot of times clients will actually feedback to us saying that, oh, this kind of tools, right, it can't exist physically in a classroom. And so that is something that they actually want to continue using even after the pandemic has ended. So I guess the pandemic actually pushed people to start using online tools, but the advantages of the online tools will then keep them using them even after the pandemic has ended. And that's something that I think how technology has come into play within the past year. How about you, Emily?
For me, since you have covered about how technology has changed quite drastically over these past 2 years, I'd like to make a slightly different point. For example, this is quite related to the previous slide that you might see. We use quite a few different technologies, and I think what is very important in tech, and especially when you're building production apps, is that you do not really seek to reinvent the wheel, but you seek to use existing very optimized tools and you build upon them, which I think is very important. Of course, if you would like to learn to make new things, you would try to reinvent the wheel and build something from scratch. But once you're making something that is gonna be released to production, I think it's wiser to just use an existing package and actually extend the functionality of the package rather than to make something from scratch by yourself. And this is actually very common where you see a lot of different different startups that provide many services. For example, Stripe is a very popular payment platform that people use to like handle buildings within their application. That's all.
All right. So you want to go into this, Emily?
Well, so about a career in tech, I think it'll definitely be very exciting. There'll be a lot of new opportunities in the field of technology in the near future. And there's definitely a lot of like ways in which you can contribute in terms of your technical skills, for example, in like cybersecurity, machine learning, software development, etc. And probably in just a few more years' time after we graduate from university, or even if you just entered university, you will probably find yourself like in a world where there will be some new tech jobs that emerge, even if that you probably may not have considered about it right now. And with any tech, I guess you can make a lot of contribution in terms of the impact that you might make on other people's life. Like even if it's just something as simple as improving productivity or making a contribution to like the larger spheres like hospitality and tourism, etc. What about you, Zenon?
I fully agree with what you just said there, and I think this kind of like so you know, this kind of career in tech, you can actually you can a lot of times you can push the boundary of computing, push the boundary of technology in what kind of stuff that computing can actually do. For example, you know, like back then there has never been like this kind of like photorealistic graphics rendering, but now we are kind of seeing real-time tracing being brought to homes all over the world, and you get all kinds of like very all kinds of technologies that wouldn't have existed back then. Or you can also have a career in tech that that is not so much about pushing the boundary of technology, but rather it's about finding new ways in order to use technology. For example, you know, in connecting to people, in talking to people across the internet, in chatting with people, playing multiplayer games with people, you know, bonding with people with other different ways that wasn't possible back then. And that's also something that technology really brings to the table. And I think Emily has actually talked a lot about this just now, and I think what she said was quite concise already. So I guess that is kind of like the end of our presentation. I'm not sure if we are overrunning. Yeah, so if we have any extra time, right, I don't mind answering any questions that people have.
I think you can just go on.
As in, we have come to the end of the sharing of what we plan to share.
Oh, okay.
Yeah.
Jacqueline, do you want to close the...
I think if anyone has any questions, you guys can just type in the chat first, and then we'll just collate all the questions and ask you later. Sorry?
If I'm not wrong, I think Mr. Gee has actually left us a question. I think we can actually begin with that one, and anyone who has questions, you can actually just type it into chat, and then we'll try our best to answer them. Yeah, is that okay?
Yeah.
Okay. So Mr. Gee actually asked us, how can current students better prepare themselves for internship opportunities? For me, right, for me, this internship opportunity actually came to me, and I think I kind of have to think about this for a moment. Emily, do you have anything to say? If not,
This one also kind of like came to me. I guess to help you in like seeking internships, it's very important to have like different. You need to have like a positive learning attitude and have some evident showcase of some of your works and your projects, which I guess will be a very helpful testimonial for your like, abilities.
I think I also share the sentiment that Emily had, and in a way, it's not so much about the qualifications that you have. Like I have like 10 years of experience in computing. Yes, experience do have a lot of bearing, but it's not everything. And I think if you want to be able to acquire an internship opportunity, not only do you have to go out looking for it, connect with a network of people who might be able to find these kind of opportunities, but also you have to keep that kind of open mindset in order to try different stuff, in order for you to be able to learn what it takes in order for you to be able to contribute when you are at this internship. And so that's more regarding how you can actually prepare yourself for the work that you have to do during the internship. In terms of how you should prepare to get an internship, I think it's more about how passionate you are at something. If you actually take the time to learn other stuff, like something that is like not required for you, in your academic studies, whether you have the kind of passion for you to learn more than what you need in your academics. And if you can show that kind of passion to the opportunities that you find, I think it will be easier for you to secure such an opportunity. Of course, you also need to be able to communicate with people. You will have to be able to talk to people around you regarding the things that you would like to do, the things that you are open to, the things that you would like to try. And oftentimes, when these kinds of opportunities come, you'll be able to find it. You'll be able to take it.
I guess like a lot of similar to a lot of other things, the first step is always the hardest. But once you have overcome it, I believe the rest of your journey should flow more relatively easier.
Do we have any other questions? If not, maybe we should pass the time back. I should yield the time back to the organizers.
So does anyone have any other questions? If not, I think thank you, Emily and Zinan, for telling us so much about Classdo.
And thank you for inviting us as well.
Now let's move on to the next thing. So do you remember on the first day we had a welcome address? So of course we have to have a closing address. So let's invite the organizers and people to tell us, to talk to us about the closing address.
Hello, I'm Yokhan. I'm one of the event coordinators of BuildingBloCS 2021, and I'd like to give a huge thanks to every single participant who has been here with us for the past 3 days. In fact, I can actually recognize some of you who has been here with us since Saturday. Thank you for taking a time out of your June holidays and spending them with us. I know how hard it is to wake up so early, especially during the holidays. So I'd like to applaud all of you here for your hard work and dedication towards computing and self-improvement. A year ago, I was actually one of the participants of BuildingBloCS. BuildingBloCS was the first ever computing event that I attended since I started on my computing journey. I was only 3 months into learning computing, and as most of you here can relate, learning a new skill is not easy. I was feeling overwhelmed by my peers around me that had so much more experience and knowledge of computing, which I'm also sure some of you here might feel the same currently. But BuildingBloCS gave me the motivation to carry on through their activities like Code Combat that taught me learning can be fun too, and keynotes from various companies that inspired and motivate me to carry on. So I hope that BuildingBloCS 2021 can do the same for you as it did for me. We will all still be here for you after the event on Discord, where you can feel free to ask us various computing or non-computing related questions, or be notified of any computing related activities or courses outside of BuildingBloCS, or just to chat with us or each other in general. For those that might have started your computing journey with us and felt like you didn't understand certain parts of our workshop, I want to assure you that it's completely normal and I understand. So do note that all of our workshops will be uploaded on our YouTube channel. We have a wide range of topics there, and we hope that at least one of them would interest you. So if you wish to explore other areas of computing that aren't covered on our YouTube channel, feel free to talk to us on Discord and we can give you relevant links or videos that might be helpful for your journey. Even if we don't know much about the topic, we can research it with you and learn together as a community. No matter what your background is, we are all here to learn from each other, and I hope that BuildingBloCS can be the platform for you. We hope to see you soon on Discord, next year's BuildingBloCS, or who knows, we might even be future schoolmates or colleagues. Good luck on all of your computing journeys, and now I'll pass the time over to Yik Ting.
Hello, hi everyone, I'm Yik Ting. So I'm the event coordinator of the AIWinpetition for BuildingBloCS 2021. So first of all, I would like to sincerely thank all of you for participating actively in the past few days, be it our workshops, our conference. And as we come to the end of the Winpetition, I hope that this has been a fulfilling experience for all of you. It's already really hard to come up with a creative and feasible idea in such a short span of time, but all of you managed even a prototype. So I would like to applaud all of you for your efforts throughout this competition. We hope that you have forged new bonds and learned more about AI skills through implementing this project. The Winpetition was meant to be an experience that everyone wins. So therefore, after this competition, I hope all of you take home the spirit of continuous improvement and further progress into AI. And as Yokhan mentioned, the journey shouldn't stop here. So starting off with a simple idea of creating this competition, we spent the past weeks writing plans, settling schedules, as well as coming up with resources which we hope help you. And finally, we execute our plans. And developing this idea into a reality took a lot of work. So with that, I'd like to bring the attention to our fellow organizers. It has been a real opportunity to work with everyone and host this event. Thank you to our organizers who have facilitated the icebreakers and supported our team all along the Winpetition. It has also been such a fruitful experience working with the event coordination team. After these 3 days, we can finally get some sleep. And although we did face some hiccups in between, I appreciate everyone who played a part in making BuildingBloCS 2021 possible. So Mr. Gee once mentioned, and although I don't remember the actual quote, but I'll try and describe the general meaning. So while planning for this event, the impact on us organizers is huge, but maybe even bigger than the learning of participants. This conference has not only allowed all of you as participants to learn new skills, it also has allowed us as organizers to grow and reach out to experiences which are so rare. And this is much more than just learning computing knowledge and skills. No matter whether it was the interaction with other organizers or participants, it was a great time for me. So that's all for me, and I'll see everyone around here. Cheers. Now I'll be passing on the time to Melody.
Hi, I'm Melody, the Quality Assurance or QA Event Coordinator for BuildingBloCS 2021. Now, let me just start off with a sentence I'm sure almost every workshop speaker, competition team organizer, and fellow event coordinators have heard at least once. How do you all feel? How over the past few days, I've heard various answers. Feeling good, feeling tired, feeling happy. I'm really thankful that organizers and participants alike have taken time off their busy schedules and sacrificed their beauty sleep for attending our workshops, conference, and competitions at 8 a.m. in the morning. Without all your active participation, this year's event would not have been a success. As we come to the end of a week-long series of events, I would like to take the time to share a little bit about my organizing journey with everyone here. I signed up to be an organizer for BuildingBloCS 2021 as I was pretty worried about my VIA hours and my portfolio. I'm pretty sure most of you here know how COVID pretty much reduced our chances of holding traditional in real life VIA events. Immediately after signing up, I was worried about how much I could contribute as I'm not really well versed in skills like video editing, web development, or do not possess enough knowledge about computing related topics to plan a workshop. But the great thing about volunteering to be an organizer was that I still managed to find ways to contribute by being part of the QA team, while doing some sideline admin tasks, like setting up the event page that you guys use to get your tickets, and generating a daily list of participant signups for the various events. And through this experience, I realized that volunteering is not about how many VIA hours you get, but about the experiences you gain through the process of organizing the event. For those of you who are confused about what QA is, like I initially was, my responsibilities revolved around ensuring all work produced and associated with building blocks are of a certain quality. By attending dry runs for the workshops throughout the month of May, where each workshop had an average of 2 dry runs, I managed to learn so much more new knowledge across the spectrum of computing. For example, from learning a new programming language from Introduction to C# to learning to do simple surveillance on the internet from basic reconnaissance in cyberspace, as well as learning the basic knowledge of AI training from Introduction to Machine Learning. My point is, you don't have to be a fantastic coder or have really vast knowledge with zealous skill sets to volunteer as an organizer. As long as you're passionate about the topic of computing as a whole, with a willingness to learn, the BuildingBloCS OICs are happy to welcome you on board. Through the whole process, I've made new friends, improved on my own work ethics, and gained invaluable insight to the working world of computing from the various keynotes scattered across the June conference. I can proudly say that I do not regret my decision to sign up as an organizer. Thank you to all the organizers for putting in so much hard work. This experience of coordinating the June events is something that I will remember for years to come. Now, if you're interested in gaining new experiences by becoming an organizer for next year's event, do fill in your email in the feedback form today and we'll contact you again. Be it at the next BuildingBloCS event or sometime in the unpredictable future as classmates or even work colleagues, I'll see all of you soon. For now, I'll pass the time on to one of the funniest MCs I know, Jun Hong.
Okay, hello everyone. I was told this was a formal speech, hence the dressing, but you know, whatever, this is fine too. So a quick introduction for those of you who do not yet know, I am Jun Hong, but most of you may know me instead as the clown who fell off his chair because he was afraid of 2D dinosaurs. So just like the previous 3 people, I'm also one of the event coordinators for BuildingBloCS 2021. And as Melody has mentioned, I strongly urge those who have the time next year to sign up to be an organizer. Trust me, it's worth it. And I guess as proof, I'll share a bit of my experience as to how I became an organizer. This is when emotional music needs to kick in. Okay, So like Johan, I was also a participant in Building Blocks 2020. During March this year, I saw the announcement on Discord informing us about the signups for those who want to be organizers. I discussed with one of the other organizers, Shangen. I believe he is here today. If he is here, please, Shangen, if you're here, please like turn on your camera and say hi. Yep, that's him. And then I then concluded that because I do not trust my abilities in conducting any workshop well or facilitating the games, if I were to be an organizer, I would choose to be the MC. If I were to be the organizer. Fast forward some time, and by some time I mean 5 minutes, I received a text from Shangen telling me that he has told Joel about me. What a snitch! Anyway, before I knew it, I earned the MC role on Discord, but that's not the end. As Melody has mentioned, you do not need to be good at coding to contribute to building blocks in your own way. Soon enough, I found myself in the QA team as well, even though it was never given any confirmation that I was in it. It's just unofficial. And I was involved in sitting through the dry runs for the workshops and giving my feedback, which is kind of ironic considering that I did not trust myself to conduct any workshops. And also some video editing for the code combat tutorials. And now here I am giving you a speech of why you should join us in the organizing team for Building Blocks 2022. Well, not me, because I'm graduating. See you! Anyway, my point is, if you feel that you are able to commit, please sign up to be an organizer. It is really a rare and rewarding experience that I am very thankful for. You will not regret it. Okay, I'm done. Stop the emotional music. Jokes aside, really please do consider signing up to be an organizer next year. And for now, I'll pass the time back to the MCs. Oh wait, I forgot I'm the MC. Anyway, so when did my clothes change? Anyway, now we'll be having the photo taking session. It'll be the last one for today. So can everyone please turn on their web cameras? Steve, can you stop screen sharing? All right, thank you. And we'll give you another 20 seconds to turn on your cameras. Okay, time's about up. So can Ray Yang help us to take the picture?
Yep, give me 1 second. I need to switch. Okay, hold on. All right. Okay, so on the count of 3, I'm going to take a photo. And you know what? For prosperity's sake, we are also going to be recording this. So feel free to do any reaction that you want to do. All right. But on the count of 3, for the next 5 seconds, we'll be recording this. All right. So 3, 2, 1. And with that, I'll pass the time back to the MCs.
Okay, so this will be a quick announcement. So there's a computational thinking webinar on 5th June from 10:30 to 11:30. So for those parents and students who are interested in signing up for it, is by Prof. Leong Hon Wai from the School of Computing, NUS. So if you like to sign up for it, the link will be given in the chat. It has been given, so we shall move on to the next portion.
All right, we would like to thank once again our faithful partner, AI Singapore, as well as all of the keynote speakers, workshop speakers, as well as the facilitators who has made this event a possibility.
Now, I shall thank the AIWinpetition team as well, who has spent a lot of time on the AIWinpetition that you have just done. The Code Combat organizing team for organizing the Code Combat tournament, as well as the Code Combat workshop, as well as all the event organizers who have been working hard behind the scenes to make this possible. And of course, I would like to thank all of you as well for joining us in the past week. So for the AIWinpetition, please remember to keep an eye out for any announcements in the announcement channel on Discord. Remember that voting is tomorrow and the results will be released by Sunday, 2359. And of course, we must not forget the last piece of the puzzle, all of you, for making this event possible. So from the bottom of our hearts, 3, 2, 1, thank you.
Thank you. We sincerely hope you have enjoyed this 3-day conference, and we hope to see you again for Building Blocks 2022. That's all, folks.
Okay, but not to ruin the moment, but before you guys go, obviously there's one more feedback form that you guys have to do for us for day 3. So after you've done the feedback form, you guys can leave, and we hope to see you guys next year. Bye.